Welcome to the course on Learn Python in 12.5 hours. My name is Anthony Ng. I will be your instructor. Now, a little bit about my background is that I was a banker and my training is in the area and field of quantitative finance. My formal training is in the areas of financial engineering. Now, Python is my main programming language for general exploratory analysis, such as data analysis, analytics, as well as algorithmic trading. And the other part of it is that I use it to apply a real-world problem using such as machine learning and deep learning to solve investment problems. So if you explore my website, you will be able to find a few things about me, some of the courses and talks that I've been actually giving. So you can actually look at some of the previous engagements that I've participated in, and feel free to browse through them. Some of them has videos to go with it. So what are you going to learn in this course? First of all, I just want to explain the approach. Now, Python has been around for a long time. If you just go online, Google, and type Python, you will most likely see millions and upon millions of hits. And there are not short of resources and books online as well. I'm going to show you some of these free books online. Now, what I find is that having taught this in my school for quite some time, the hardest part when it comes to programming, and this includes Python, is getting started. So this course is designed to get you started really quickly. It is like a boot camp, but the point is actually to get you up and going in an extremely short time. Right now, the content is only 4 hours long, so if you just invest that 4 hours into learning all the basics of Python, hey, you have a very solid foundation to go very far from there. What about the remaining hours? It's 12.5 hours to learn, right? We've used up 4 hours. What about the remaining 8.5? Good question. Wait around. When you come back, I'll come back and explain that a little bit later. One other thing is that I follow the official Python documentation really closely so that you can actually refer to it. Now, one other thing about open source software like Python is that the version is constantly changing. That's because new features are being added all the time. Now, you need to be able to go back to the official documents and actually continuously upgrade and continuously learn yourself. Now, all the scripts for this course are provided, so all you have to do is actually follow this link and you will be able to actually access all of the codes. It's provided for you for free. Okay, now I did mention there are lots of resources online. As you can see, I've provided these and all the associated links as well. Some of them are books, like Shepherd provided a book 400 over pages thick of books. You can also learn Python via Python tutorial, Codecademy, Kaggle, and on and on. And finally, what would you learn in this course called Learn Python in 12.5 hours? You will start off from a so-called motivational example, learn to use Python like a calculator. You will learn things such as variables, value assignments, and some of the data types such as strings, lists, tuples, sets, dictionary, numbers, how to control flow, define function, manage modules, import, make use of modules, input and also output, and finally handle errors and exceptions as well. Now, let me come back to the last question that we did ask. Look, this course is 12.5 hours. The content is only 4 hours. But before I go on further and explain it, I will add further content as the days go by and add some new and fresh and useful, interesting contents for you. So, question about the remaining 8 hours is for you to actually practice. Now, learning how to program is just like learning how to cycle, learning how to drive a car. You have to practice. That's the only way that it will go from book understanding or mental understanding to muscle memory until it becomes second nature. That's really where the remaining 8 hours will be. I will be uploading a whole lot of practice problems for you and for you to actually practice and continuously practice until it becomes a second nature to you. Welcome to the course on Python. This is our first lesson on a gentle introduction to Python. We're going to make use of the Microsoft Azure notebooks online so that you can actually get started quickly without worrying about the installation of all the Python software. So what I want you to do is actually type notebooks.azure. Let me just zoom in. notebooks.azure.com/Anthony Tyng. Okay, notebooks.azure.com/Anthony Tyng. Don't worry, I will provide the link for this as well so that you can actually directly come to this. You will come to this, there's libraries here, Python and 0 clones, and modified on 13th of February 2018. What you do need to do is actually come to this, and you can see all of these files that's provided here. There are 2 pages of them. There may be more as I add more files. Essentially, these are the codes for the whole Python course. So to begin with, what we do is actually we start with the first one, which is Gentle Introduction. Okay, you click that, it will bring up all the codes for you so you can actually follow along everything that I'm doing. So let me just close that off. In order for me to run them one by one, I do need to log in. So for you to actually be able to run and follow along when I'm actually running this course, you do need to log into a Hotmail or Outlook account or Live account. So once you're logged in, you'll see this green fonts here called Running. All you have to do is actually select this Gentle Introduction 03. This is our first class, and you will see the so-called Jupyter Notebook. So this whole outlay is Jupyter Notebook. So you have the heading here, and this is running on Azure, so they call it Azure Notebooks, and this is the Python font, and these are the manual control. Okay, so let's just zoom in a little bit so that you can see clearly what I'm doing. Okay, so really this part is what I call an informal introduction to Python. Now I've provided a link here for you to actually refer to. This is the so-called original source of the codes. The purpose that I'm doing this is so that it's really about getting you started quickly, and I also want you to be able to refer back to the original documentation so that you actually have there's no cognitive dissonance for you, so that you can actually easily follow along. The codes are similar, but the examples are very, very different. I've modified to illustrate some of the concepts differently. Of course, you can go back to the source to look at it, and hopefully it should look familiar to you. Now let's start with this first cell here. You see that there's an in, there's a bracket here. This is what you will call a code cell. You can change that to a markdown, which is what this first block is. Notice that this highlights the first block. Markdown basically is another form of LaTeX. It's basically to write beautiful fonts, okay, for you to control the font types. Inside it, I provided a link so that you can actually open up this easily. Now this cell here, right, notice that it's now highlighted. It's called code. It's a code cell. So if you want to run this, what you need to do on your keyboard is press Shift, while holding that down, press Return. And then you will see this 1 pop up. Earlier it was empty, okay, like that. Now there's a 1. So that means that this has been run, this line of code has been run. And basically the line basically is say import sys, which is short for system, and print the system version. What I wanted to know is which version of Python am I running here. It's 3.63, Anaconda custom 64-bit. The default is November edition here. So it's telling me this is Anaconda, okay, version of Python. Alright, so let's dive into it and look at using Python as a calculator. Now a couple of things that we're going to learn from this is that first of all, we learn about the various data types, integer, float, and also learn about operands, variable name, value assignment, and also determining the data types. Don't be too concerned if all of these is just too much information. We will go through this one by one just so that you are familiar with it. For a start, we're using Python as a calculator, all right, so that you actually learn how to interact with this Jupyter Notebook. Now, Jupyter Notebook is very popular amongst the scientists and also academics because it's great for sharing. As what I'm doing right now with you is fantastic for sharing. You've got the code now. As long as you logged in to your Hotmail, you can actually run with it. Alternatively, you can download this offline as well. You can actually run it on your own desktop or laptop as long as you have a Python version installed. Right, you probably still remember this PEMDAS. Basically, that's the order of operands. So we're going to go through these one by one. What is 2 plus 3? This is really addition, and hopefully that's not too, well, at least you are familiar with that. So you can actually press Shift, Return, or use this button here, Run. That will run the one cell. Okay, the input, this is cell number 2, is 2 plus 3. Okay, what you can see here is that I have used the hash, which means comment. Whatever that's after the hash will not be run. Basically, within the code cells, this is telling the Python that this is a comment. Okay, so don't run this part. So you have 2 plus 3. Thank goodness it works out to be 5 as we suspected. You can do likewise with 6 minus 4. Run it, and it gives you 2. And now, if you take 20, this is represent divide by 4. When you run it, you get 5.0. Notice there's a slight variation here. Here we have 5, and over here is 5.0. Now the 5.0 means that this is a float. A float meaning it's not an integer, it has decimals that follow with the whole number. So let's look at some multiplication now. If we run this cell, 6 times 7 is 42. Notice that that's an integer. And if you actually use parentheses, that takes priority over the operation order. And 3 plus 5 gives you 8. Divided by 2 gives you 4. Notice that this is a float. If you take 21 divided by 4, which is a normal division, you get 5.25. A float division is double slash. Okay, whereby the fractional part is actually discarded. And what you get is 5.0. Notice that the 1 over 4, the 0.25 part, is being completely removed. Alternatively, if you want the remainder, you can use the percentage sign, which gives you the remainder of the division of the leftover, okay, which is 20 divided by 4, and what's left is actually 1. And if you want to calculate power, this is 2 to the power of 4, which gives you 16. Alright, so as you can see here, you can actually use Python as a calculator. It works just like a normal calculator that you operate on. And you can also combine multiple operators as well as mixing floating point numbers and integers as well. Now, when you actually mix integers and floating point, what you will get is actually floating point. Take, for example, we have 3 times 8.75 minus 2 dot. 2 dot here represent that this is actually a floating point. So when we run that, we get a floating point, a float, which is 24.25. Now, so far, what we've done here is that we use Python as a calculator. Now, I'm sure by now you find that, hey, this is a bit tedious. Every time I want to do some calculation, I need to actually type this in. What if I'm doing repetitive tasks that do I actually have to type this in every single time? That's the beauty of programming, is that you don't. You can actually store your value into a variable. Okay, but you do need to give your variable a name. In this case, the variable name that we call it is no underscore rows. That means number of rows. So what we're doing here is assigning 5 to the variable called no rows, or number of rows. And when we run that, nothing is displayed. Okay, so let's just say, all right, what about number of rows, number of seats per row? Here we have 10. Now, I'm sure by now, hopefully, if you still remember your high school math, you are actually getting where we're going now. Is we're looking at how many seats are there in this room? There are in total 5 rows, and each row has 10 seats. How many seats are there? Okay, so let's run this, and what we get is 50. 5 times 10 is 50. So what you can see here is that you have store or assign the value 5 into a variable. So now you can keep using that variable again and again and again for other purpose. Now what happens if I haven't assigned a value to a variable? What will happen? Let's look at this case here. M, earlier we never made assign any value to it. So what would happen? Okay, as the comment probably by now tell you or informed you that you are going to get an error. Now, having an error like this is not the end of the world. It's basically Python giving you useful information for you to actually track down where you've done, where you've made a mistake. So what you have here is that the name error, all right, is telling us there's something wrong with the variable m. It's not defined, okay? So literally that's telling us that, hey, we have not defined or assigned a value to m, whether it's a string or integer. We haven't actually given it, assigned a value to it. Hence, we get this error message. Okay, so let's just recap. What we've covered is that we use Python as a calculator and also learn how to perform value assignment. So let's take a break and we'll come back and figure out how to determine a data type, because we've seen a couple of different data type now. We've seen integers, we've seen float. How do you tell which is which? So when we come back, we'll look into that. Welcome back. Right, we're going to move into determining the data type now. Python has very nicely and kindly provided this so-called code or method or function that allows you to determine the data type that you're working with. So type bracket 4, so it will tell you that it's int, an int, and int stands for integer. So what about 4 point? It tells you it's a float. Okay, what about if I have 4 plus 5, what do I actually get? All right, now if it's 9, how do I know what kind of what type or data type is it? So let's just pause for a second. I'm going to ask you to actually try this out, all right, yourself, and what would you do to determine the actual data type of the output of 4 plus 5? Alright, I hope you actually given that a try. So let's just add a line here. How do you add an empty line or empty code line? There is this plus here. Just click that insert a cell. Alright, so if we actually insert the cell and type 4 plus 5, what do we get? Okay, run this and we get int. Okay, so let's just do 4 plus 5 again. So we get 9, so that tells us this is actually an integer. Now, what happened is that the Python using as this so-called underscore variable, which actually store the last result. So you can actually perform further operation on it. So in this case, it's really you take underscore plus 1 and you get 10, which is really adding 1 to the previous answer, which is 9 here. Now you do need to be careful if you are operating with non-integer or non-number, you may get an error message. But you know, the key thing now is just to remember that what this underscore function is, it actually stores the last result in this variable, which will be discarded in the future. All right, that's why it's actually stored in there. But in case you want to use it, in a quite a temporary manner, that's why it's actually there. So let's move into strings. Under strings, what we're going to look at is a couple of things. How do you conduct an object creation of string. How do you create a string object? What are the syntax? Print, special keys, concatenation, working with strings, indexing, slicing, immutability of strings, and length of strings. Now, I know, once again, this is basically a torrent of information that's coming to you. You might need to watch this a few times just to let these sink in, because these are obviously new concept for you as you're looking at it for the first time. There are a lot of information to take in, and one of the things about programming is that you learn faster and more and grasp more by doing. Okay, so it's good if you can actually try along or follow along by typing your own code as well. So let's just start with the first thing that we want to do here is how do we create a string object? So you have this apostrophe. Okay, here we have strings. You can actually create it by single quote or double quote. Okay, so we're going to create a string object called last emperor by using single quote. Okay, so there you go. What you have there is actually a string object. What about double quote? It does the same thing. Okay, notice that it gets reduced to single quote. Now there is a reason why we actually do that. The next example will show you. And now occasionally, obviously in English, there is apostrophe in some of the sentences, like emperor's new clothes. If you do single quote, you're going to get an error message because you have to encapsulate the whole string in either the single quote or double quote. So in this situation, what do we do? Okay, we need to actually use double quote rather than single quote. Okay, so hence you use double quote here, as I mentioned in the comment or mentioned or highlighted in the comment. You use double quote to work around the single quote, and you won't have that problem anymore. And notice that Python quite smartly picked up that you're using double quote to create this strings, string object. Alternatively, you can use this, which is the escape key or special key here, which allows you to work around the apostrophe there. So it actually picks that up as well. Now from time to time, as one of the way to learn quickly, you want to actually interact with the Python interpreter, which is what we're doing here with this notebook, is to display all the information onto the console or the screen. And you use print to do exactly that. Alright, so we're going to run this cell, and what you see here is that it print line 1 and line 2. Notice that this is quite pretty. It doesn't have that ugly single quote or double quote in that's displayed with the actual text itself. That's what print does, is that it prints out the actual onto the console the actual variable value. In this case, it happens to be a string object. So what about if we print this? And what you will get is actually this really funny outcome. You have single quote here and C semicolon slash Dropbox slash new. It's supposed to print like that. But what do we get? Instead, what we get is actually Dropbox and then you on the next line. This is because slash n is a special character in Python. It means new line. So to work around this, we add a R before the actual first quote. This informs Python to use raw strings within the actual quotation itself. So let's run this, and voila, it actually will solve that problem that you faced with earlier. Other things that you can do is that you notice that we are printing multiple lines here. Okay, sometimes the output that you want to actually provide can be quite long, so you use multiple line in this case. Okay, the other alternative is that you can actually add this backslash. What happens is that when you actually print, typically it adds a blank line here. So when you actually put that backslash, it removes the blank line. Now, one thing that I omitted, and hopefully you picked that up, is this. Notice earlier when we do print, we use single quote. You can also use double quote. It doesn't actually change much. But the difference here is that we use triple quote. Now the purpose of the triple quote is so that you get this multiple line outputs. Okay, right? So that's really the purpose of using multiple lines or triple quote here. All right, so the backslash, as I mentioned, prevents automatic inclusion of end of line. One of the beauty of Python is that it is a really powerful language that allows you to manipulate text very, very easily. Now, have a guess. What happens if I do this? I have a string object with a plus and then another string object. Let's try that out. What you get is actually a creation of a new string object, and you get I love Python. So the plus here is smart enough to know that it is no longer, you're not working with integer or numbers here, you're actually working with a string object. It actually picks that up. So what it does is that it concatenates this through two strings object. What happens if I do 10 multiply Python? What I get is 10. Okay, Python repeated 10 times, and that's actually also a string object on its own. What about this? If I have Python within double quote and then a space and then a double quote with red in it, what actually happens? It actually merges the two automatically. So note the comment here actually also say automatically you have a concatenation of two or more string literal, which is a fancy word for string in quotation when they are next to each other. Right, let's finish off this part before we take a break to come back to indexing a little later. I just wanted some of these concepts to sink in. So we have a sentence here, my dear wife listens to space the latest K-pop. Now what do you think that will be? Alright, so let's run this and you won't see anything. Have a guess again, you have one last chance to guess. Would it actually do exactly what we just learned in the code and output number 34? Let's have a look. Voila! Okay, it automatically concatenates two or more string literals just as we expected. Okay, notice the reliability and the consistency in terms of the performance here. It repeats itself, it doesn't actually deviate from that. That's really what we want, is that the behavior doesn't change. Alright, so we have prefix is equal to that. Okay, so what happens if we actually put these prefix and then uno? Essentially what we're trying to do is actually we try to get to Arduino, right? And you probably, if you read ahead, you already can see it here, the variable cannot be concatenated to string literals. So we're operating with another different object here. Notice is variable. We looked at variable earlier, okay, and now you notice that you cannot concatenate the variable to a string literals. Okay, so that's one of the rules in the syntax of Python. But you can put a plus. All right, if you put a plus, it will automatically combine or concatenate the two string, and what you get is actually Arduino. All right, so what have we covered so far? What we've covered, let's come back up here, is how to determine data types, right? And also a couple of things about string, how to create a string object, the actual syntax, print, special key, and concatenation, and finally working with strings. When we come back, we're gonna continue on working with strings and also understand how indexing and the rest works. All right, I'll see you in the next video. Welcome back. We're going to move into indexing. In the last portion, we talked about string and how to actually create a string objects. In this lesson, we're going to cover indexing. All right. So one point here that I highlighted is that Python uses zero-based indexing. What does that actually mean? It means that Python starts counting from 0. Okay. So 0, 1, 2 means there are three separate entity here. So keep that in mind. Now let's start with assigning a value called Arduino project book onto this variable called sentence. Okay, so that's what that is. So what we are trying to do here, this is called indexing, is that sentence bracket 0. We're trying to actually find out what the character in position 0 is. And as suspected, is A. So this is what it means by indexing. You are actually trying to find out, all right, or index what the actual so-called individual character is for a string. So what about number 4? Okay, so this is the catch here. This is actually character number 5. So let's just start with 1. So 0, 1, 2, 3, 4 is actually I. And as we suspected, it comes out with an I. What about minus 1? Minus 1 actually refers to the last character. So in this case is K. What if it's actually minus 4? Okay, let's run this. And it's actually B. So it's minus 1, minus 2, minus 3, minus 4. So that's really how indexing actually works. So I'm going to introduce to you another concept called slicing, which is very, very similar to indexing, but there's a slight variation here. So let's have a look at the sentence, okay, from what we created before. Okay, still Arduino project book. So earlier when we're doing indexing, we're indexing 1. Okay, only ones or single digits, so we actually get A. So what about if it's 0 to 3? This is an operation that is called slicing. So with this, what you get is actually 0, 1, 2, 3. Okay, so start from 0, stop just before 3. So 0, 1, 2, 3. So that's why you get ARD. So that's really what this is. What about 8 to 15? Okay, so let's just try this ourselves before we do this. 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, that will be P. 9, 10, 11, 12, 13, 14, 15. So if we are correct in our counting, we should actually get the word project. And voila. Okay, it turns out as that. What happens if it's minus 4 and then dot dot with nothing? What do you think that is? Okay, let's try it out. It turns out that it's 0, minus 1, minus 2, minus 3, minus 4 onwards. So that means all the way from minus 4 all the way to the end. So that's why you get book there. What if we actually give 14 to 24? What do we get? We get T and we stop at K. Wait a second. Earlier when we actually counted 15, which is here, 16, 17, 18, 19, 20, hey, 20 is already beyond the length of the actual sentence itself. Notice that Python has handled this masterfully. Doesn't show any errors because it actually picks up, handle this gracefully for you. But unfortunately, it won't handle this gracefully if you're actually trying to index out of the range, and that's why you get this error. So from now on, if you see index error and it's followed by string index out of range, then you know that you're actually trying to index outside of the length of the actual sentence itself. Okay, but in the case, just be mindful of this, is if you have a double quote like this, it doesn't actually display any error message. So this is one thing, just be mindful of and be careful when you're working with this. Now, before we move away from strings, there's just one characteristic of strings that I do want to highlight. Strings are actually immutable. Now, what does immutable? It's a really fancy word that means you cannot change the value. Okay, so remember, a sentence here is Arduino project book, and what if we try to insert a M, replace 0 with M? You will actually get this error, type error. str, which stands for string, object does not support item assignment. That's another fancy word for saying, hey, you cannot change me. I'm a string, do not try to change me. Okay, but you can, however, add an M to the actual sentence itself. And you get, instead of Arduino, you get Maduino. What happened to the A? Now the reason that the A is no longer there is because we started off from 1. Remember, Python start counting from 0. If we actually start the slicing starting from 1, A is automatically not included in this. Hence you get Arduino, I don't know how you pronounce that, instead of Arduino. Finally, there's just one function or method that I want to show you. It's called len. You probably guessed it. It's to tell you the length of the actual sentence itself, which is 20 in this case. Okay, so that means there's actually 20 characters in this Arduino project book. Okay, that's how long that is. This is very useful, especially when you're trying to figure out how long is the sentence that you're actually trying to work with. Right, we're going to stop here. That really concludes everything to do with strings. When we come back, we're going to cover another topic called list. Welcome back. Let's look at list. Alright, so we've covered numbers, which is integer, floats, and the like. We also cover strings. That's another second data type. Now the third type that we want to look at is called a list. Alright, in the list part here, we're going to cover a few things, the learning outcomes. We want to know how do you create list, how do you index and slice. Notice that these are the same concept as string, except that we are working with lists rather than strings now. So let's start with this. So in order to create a list, you use a square bracket, okay? And what we're doing here is that we are creating the list, which is 2, 4, 6, 8, 10, and then we're assigning this to the variable called list of numbers. Okay, so let's just print this, and there you have it. Okay, so when you actually try to just have a line which says list of numbers, the variable name, what it will do is to actually give you the output of what the actual value is. Now the beauty of a list is that you can index it and also slice it. Very similar to string that we looked at in the last lesson. So if we index 2, okay, that means is 0, 1, 2 is the value number 6. Minus 1, as we know from last time, is the last value. 2 to 5, remember, it's 0, 1, 2, 3, 4, 5. So that gives you 6, 8, and 10. What happens if we actually add? Well, they basically add the actual list onto the list itself. So it extends the list now 2, 4, 6, 8, 10, and then 2, 4, 6, 8, 10. It doesn't add them together. All right, it just extends it. Now one thing to bear in mind is that lists are mutable, unlike strings, whereby with strings you can't change it. That's why it's called immutable. But with list, it is mutable. You can actually change it. So the contents can be modified. So let's just print a fresh copy of list of numbers so that we can remember what list of numbers are. It's 2, 4, 6, 8, 10. So what we're doing here is that the list of number 2, we want to change or assign a different value 44 to item number 2 or index number 2, 0, 1, 2. So basically we're looking to change 6 to 44. Okay. Right now we can't tell whether we've actually done it correctly or not. So we have to run this cell to be able to tell, oh, okay, it has indeed been changed successfully. You can also add value to the list by extending it. You use this method called append. We're trying to append 20 to the end of the list of numbers variables here. When you run that and look at the output, sure enough, it actually adds another item onto the list itself. Alright, the next thing we want to do is assignment of value to slices. Alright, so let's look at, bring this up again so that just to refresh our memory. Okay, so what we are doing is 0 to 2 is equal to m to n. Okay, we haven't encountered this before. Let's run this and try to figure out what it's like. Remember what 0 double dash, colon 2 means. It means that we are slicing 0 and 1. Okay, start with 0 and finish before 2. Okay, no errors. That's interesting because everything we have was numbers. Now we actually assign 2 string and I didn't get any errors. So now I'm interested to know what is in this list of numbers now. So let's have a look, and what you get is that, oh, you're right, we can actually mix data types. So we have strings and also numbers all in this one list. And that's the beauty of list, is that you can actually combine multiple data types. So let's look at the next line of codes from 3 to 6, 0, 1, 2, 3, 4, 5, 6. So from 8, 10 to 20. So these three here, we're giving it an empty bracket. I wonder what that means. Let's just deduce this, or assume, or not assume, let's just deduce this. I think it's actually removing 8, 10, and 20. So let's run that. Okay, again, no errors, and let's just print the value. And yes, our assumption or our guess actually comes true, as that it is indeed a list of numbers, indeed removing 3, 4, index 3, 4, and 5. Now, again, you can use the method len on list of numbers, and what you get is actually 3. So that's actually a very useful method that you can use it again and again. Now you can actually nest a list, meaning a list contains within another list. Alright, so let's create two lists. One is the M, one is the N. And notice that we are actually putting M and N into a square bracket. Remember how we create a list is to use square bracket. So we're doing this and store it into P. I wonder what P looks like now. And there you go. What you get in terms of P is that you have a list, two lists within the list. Alright, so that's the interesting part. So what happened if I actually index 0? I get the first list here, or index 0. Index 1 then must be 66, 24, 10. So what if I actually want to access Mary? What I can do is using index 0 and point to number 2. Actually, 0, 1, 2 is more likely to be Joseph. And there you have it. And that's really how you actually access the value within a value. Okay, it's just basically by using two index, because right now we have list within a list. Alright, so that's a really gentle introduction to list. I'm going to end there. When we come back, we're just going to go into first steps towards programming, and just to give you a general flow and idea of how things works. Welcome back. This is the first steps towards programming. This is the last part of this gentle introduction to Python, and this is the last part. Now, I'm sure if you have played games or used apps before, you'll notice that the program continues to run and wait for your instructions. And it's always waiting for you. So when it's basically, even if you're using GPS or any of those electronic devices, or running a program or Microsoft Word or Excel, it's always waiting for instructions from you. So that's really, at the back of it is actually a program that's been written. Python is obviously a programming language that can actually write these so-called programs that allows a user to interact with it. So I want you to get into this thinking head, or thinking of what or how do you actually write programs. So in this part, we're going to learn a couple of things: multiple assignment, flow control, a code block and indentation, how to do print, which we covered earlier, finally assignment and evaluation. So the task here is that we're going to write a simple program that calculates the cube for the first 5 numbers. Simple program, but to help you along to understand how this actually works, or how do you write this program in Python. Now, this is not a very long program. As you can see here, there's really only 5 lines of codes. I just press L, okay, and that gives me the line number, as you can see here. Right, let's start studying this code. We are doing multiple assignment. Okay, that means we are actually assigning not just one assignment or single assignment as we've done previously. What we did here is this is single assignment, assigning the value into one single variable. Here we are assigning 1 to I, 0 to j. While I is less than 6, that's how you read this. Okay, this is smaller than. While it's less than 6, repeat all of these. So that's a while loop that is continuous until the condition is true. What is this condition? The condition is I. Okay, as long as I is actually less than 6, this programs will run forever. As long as it's actually above 6, immediately it will stop. Above or equal to 6. So we're going to print double bracket. Okay, within this double bracket, everything will be printed. Okay, but there is this squiggly bracket 0 or curly bracket 0, 1, 2. What are they? Okay, so it's actually telling Python to go and grab the index 0, which is j here, index 1, which is I here, index 2, which is I power 3. That means I to the power of 3. Meaning it's calculating the cube. So by now, you should be able to actually roughly get the idea that, okay, if I is equal to 0, okay, I starts at 1. Okay, if I is equal to 1, info hashtag j will be, j will start at 0, so the first line of code will be j0, I is 1, 1 to the power 3, so that means I should get info hash number 0. The cube of 1 is 1. Okay, so you actually calculate this value, substitute into this, calculate this, substitute into this, and calculate, substitute into this. I'm glad I don't have to do this myself. It's just basically all done by Python itself. After that, this line is I plus equal to 1, which is asking Python to increase the value of I by 1. You can write this part this way or this way. They're both the same. I plus equal to 1 is same as I is equal to I plus 1. Alright, now that we understood all that, there is actually comment down here as well. Line 1, the first line contains a multiple assignment. I and j got the new values 1 and 0. Okay, so you can actually read all of these. I've already commented for you. I have all of these comments so that you can actually refer to them a little later. So let's run this, and we get 0, 1, 2, 3, 4, 5, which is the cube of 1, 2, 3, 4, 5. The moment that is equal to 6, the while loop stop. Alright, so the while loop actually works. So remember what I say is as long as I is less than 6, it will keep on running. But because we're incrementing I every time, alright, the first run is a 1, increase it to 2, and then go back another loop, and then 3, and then 4, and then 5, and then the last time is when it turned to 6, it comes back here. Alright, the condition becomes true, it quit. Alright, it doesn't even run these line of codes here. Right, so with that, that's really the end of this really gentle introduction to Python. By now, you should be able to actually, at the very least, if not able to do this, at the very least, you have an appreciation of the power of Python, what you can actually do with it. We've figured out that, or we learned that you can use Python as a calculator. We can, assign value to variables. We can also figure out that, hey, there are strings data types. There's also a list data types. And we even actually, list data types, we even actually went on to write a really simple program that actually calculate the cube of a list of numbers. So that should actually, at the very least, hopefully open up your mind's eye to what else you can do over time. So I've got a couple of references for you. There are 4 books here, or 4 online references that you can actually go to. Like I said before, Python has been around for a long time. There are a lot of resources out there. There are free books, there are free courses, all online, all out there for you to actually learn. And the purpose of this course that I have designed is not so that it's actually comprehensive. There are plenty of them out there. I just want to help you along to actually get you started in this world of programming really quickly. With that, I'm going to end this gentle introduction. Thank you for watching. Right, welcome back. In this session, we're going to look at the flow control, meaning we're trying to actually control the flow of the actual program itself depending on the conditions. So that's really the session that we're going to cover here. So let's just zoom in a little bit. Right, once again, there's the tutorial that you can refer to. This is number 4, underscore flow control. So you can actually run this and follow along. Now, let's start with if statements. Now, the learning outcome really out of this is to understand how the if statement actually work. In terms of format is if, and then else if, which is ELIF, and then else. So let's look at the P5 to 6 academic gradings in Singapore. Now, if you score 91% and above, you have an A star, 75% to below 91, it's an A, 60 to below 75 is a B, so on and so forth. And if it's below 20, it's a U. Right, so this is the program that we've written here. So let me just, okay, we can see everything. All right, couple of new things that we haven't seen before is obviously the if statement, and the other one is this input here. Now, what does this input do? Input here prompt the actual user, which is me in this case when I run this cell, to provide a value or enter an input. Obviously, we need to actually guide the user on what to actually provide or what kind of input to provide. So here we have please enter the raw scores. And the next thing that we do is that outside bracket here is actually there's an int. You will recall from a couple of sessions ago, we have float, we have integer, which is under the number section. Integer is really what we're actually trying to convert here from the raw input. We're actually converting it into an integer. And then assign this value that's input by the user to the results. Okay, so that's really the basic idea of this whole statements here. Right, once we actually have the result, then we go through this if loop. If it is greater than 91, which is this one here, greater and equal to 91, then we print A star. Let me come back to the end of our earlier session here, so let's just need to refresh this. Okay, so let's go to the end of the notebook. There are a couple of things that I didn't go through here. Last time we only covered smaller than, or less than. So these are the standard comparison operators that Python provide. You have greater than, double equal means equal to, less than or equal to is less than or equal to, greater than or equal to, and finally not equal to is apostrophe with an equal. That means not equal to. So what we have here is that if it's 91 and above, print A star. If it's 75, because notice that we don't actually look at the 91 anymore. The reason being, once you actually gone through this line, if the result is not greater than 91 or greater or equal to 91, it must be that it is less than 91. Okay, if it's less than 91, then it will fulfill this part, which is this portion here. It is greater and equal to 95, greater and equal to 75, but definitely below 91. Now, if this condition is not met, then the number must be smaller than 75, so 74 point whatever and below. But notice that it is an integer, so it has to be 74.49 and below, less than 74.5 in other words. So this is if this condition is true, then print this. If not, run another if, which is else if. Alright, else if is a follow-up of if the first if condition is not true. So we continue on this if statement until we actually come to the last line here is else. Okay, basically we have up to here is that if it's greater than or equal to 20, then print an E. If it's less than that, it must be that the only thing that's left is that they are less than 20, which is when that condition is met, then we print U. Alright, so that's really the if statement. So let's just run this. let's input a raw score. We put 30 and let's see what we get. It is an E. All right, 30 here, what do we get? So let's just understand this a little bit. E is 22 below 35. So we have it correct. So let's run this again. This time around we try 55, which should be a C. 55, which should be a C. Alright, so that's really the basic ideas of if statement, and hopefully that helps you to understand how it works. With that, I'm going to end this video. Thank you for watching. Welcome back. In this session, we're going to move on from the if statements that we covered in the previous session. In this session, we're going to look at for statements, also called for loop. In this part, what we're trying to grasp here is how does the Python for statements work. What it does is that it iterates over the items of any sequence, list or string, which we did from previous session, in the order that they appear in the sequence. Alright, so looking here, let me give you a check. What does this look like? Does this look like string or list? If you say list, you are correct. Right, so here we have fruit collection. You have apple, orange, guava, durian, and rambutan, mostly tropical fruits with the exception of apple and orange. So we are trying to store this list into fruit collection. Now, how does the for loop works? So, okay, what we have here is for f. Now, this f you have not seen before. In the fruit collection, which is this one here, in essence, what this is actually doing is that we are iterating over the items in the order that they appear in the sequence. So the first item is apple will be fed to f. So what you have here is that the first, okay, index 0 will be f will becomes apple, and when we actually basically the actual format of for loop is that you have for something in the list or string colon, and then you have indentation, usually for space, and what we're doing here is that we print. Okay, we print, and what are we printing? We're printing f, which is the whatever the items that's being iterated over. If it's the first item, it will be apple, and then len of f tells you the length of f. Okay, in this case, if it's apple, then we're looking at 5, which it calculates the number of characters in there. F dot upper is the dot after the dot upper is actually a method. The method that comes with the so-called variable f here. Now, in this case, f happens to be a string. Okay, upper here convert the individual characters to uppercase. So let's run this and test that to see if it works. And here we have print the first item is apple. Okay, the length of apple is 5, and then the comma, and then the third thing that we're going to print here is capitalized apple. And exactly what we actually expected. So when notice that, right, the outcome or the output exactly fulfill the definition here. Python is iterating over these items in the sequence, and in this sequence here, or basically or any sequence that you provide in the order that they appear. Apple first, orange, guava, durian, and rambutan. So in that order. Alright, so that's really how a for loop works. I hope that has been a useful guide to actually give you a quick understanding and appreciation of how it works. Okay, we've just covered for loop in the previous session. So in this session, we're gonna look at a function. Okay, this function is called range. Right? What does the range means, or what does this function actually do? This function actually generates arithmetic progressions. This goes back a little bit to your high school math, but best illustrate by example. It iterates over a sequence of number. So we're using for loop along with range here. So if you look at this, now if this is what it says it does, it generates arithmetic progressions. We have range, and then within here, inside the keyword or the parameters that we provided here is 5. What do you think it's likely to do? Well, since it says it generates arithmetic progressions, maybe it just generates 5 numbers. Well, what kind of 5 numbers? Well, the only possible kind of logical conclusion is must be from 0, 1 onwards. Okay, so what we're doing here is that maybe this is actually generating a sequence of numbers, and we're using the for loop to print these numbers one by one. So let's run this, and yes, sure enough, it does generate a sequence of number from 0 to 4. In total, there are 5 numbers being generated. You can also use range to generate the so-called arithmetic progression by specifying the start, the end, and also the step. Step meaning the step 2 here, meaning if you start at 0, it would be 0, 2, 4, 6, 8. Okay, step of 2. In this case, we start off at the low of -4 and end before 4. So let's run this, and this is what we have. Start with -4, step 2, -2, step 2, 0, step 2, to 2, and then the next one is equals to 4, so we need to stop. Okay, so this number specifies when to stop, okay, but not including that number itself. Coming back to our combination of fruit collection, right? So okay, this is a slightly different variation from what we actually have looked at before. Notice that we're actually combining multiple functions. So let's start with the inside. We have fruit collection, which is the variable that we have. We have length. Remember, length just tell you how long the actual list or string is. In this case, we have 5 fruit collections, so that numbers become 5. Oh, basically, what does that mean? It means that it's range 5. Range 5 is what we've seen before, which is 5. So now this whole line, in essence, turn out to be like that. Okay, the variation is this one. Print I, well, since I is from 0 to 4, so 0 must be stepping from 0, 1, 2, 3, 4, and the fruit collection we're combining with the index lesson. Okay, remember the index lesson that we covered previously under list? So index I would be, well, if I is 0, that would be pointing to apple, and then orange, and on it goes. So let's just print it and see whether it is as we suspected or not. Alright, indeed it is. Hopefully that helps. A lot of time, try to study the code, and that's the beauty of Python. Hopefully it's readable at the very least. Even if you don't understand how the function works, it's readable. But as you do more and more, and as you write more codes, trust me, you will become more familiar with it, and then the code becomes second nature then. Right, the next thing we want to look at is it's a new method called enumerate. Okay, enumerate. Let me just see if I can actually bring up the definition here. This is one of the beauty of using Jupyter Notebook. Enumerate. Okay, so let's put a question mark. Does it tell me? Well, unfortunately, it doesn't. Well, I was hoping that it does. Also doesn't. Okay, so it doesn't. All right, what a pity. Usually if it's a method, it will, but in this case it's not. It's actually a helper function. So let's look at Python enumerate. Okay, so Python tips 0.1. Okay, this is basically this is tips here. So here we go. Enumerate is actually a built-in function of Python. It is useful. This cannot be summarized in a single line, yet most newcomers and even some advanced are unaware of it. Okay. It allows us to loop over something, have an automatic counter. Okay, so keep that in mind. Okay, so let me just copy that so that you actually have a definition of what enumerate is. Okay, enumerate, okay, allows us to loop over iterable items. okay, which is what we have there earlier in the for loop. So iterate, okay, items and have or generate, okay, and generates an automatic counter. So let's leave that there, and obviously we do need to actually reference this. Okay, so let's reference this so that we know we got this definition. Okay, so now if you click onto that, it will just bring up to that web page. Now we can close that off now. Okay, so there are two things that we have here. Remember earlier when we're actually iterating or doing a for loop over one item or a list like this, we only generate the so-called item itself. For your benefit, K here means key, V is the value. So we are using enumerate, or rather enumerate actually can generate both the key, index key in this case, meaning 0, 1, 2, 3, and also it provides the value in that list, which is the apple, orange, guava. So it will print 0 and then the actual item. So you have 0, apple, 1, orange, exactly that. Notice that this isn't exactly the same outcome as this. The difference here is that this code is a lot more complex. This is nice and clean, basically using the helper built-in function called enumerate. A couple other things to actually grasp here. Range is an iterable object. Iterable means that you can iterate over it just like a list. Okay. For statement is an iterator. It's the very method or function you use to actually go through. Okay. List is another example of an iterator. Okay. So what is a list? List is the first time we're seeing it now. So we have range of 4. Now if you do just type range of 4, it's going to give you an object which doesn't mean anything. Okay, it's just range 0 to comma 4. Right, so if you have a list here, what it does do is that it converts this range to become a list. Okay, notice that it now no longer is an object like this, it converted to a list. Okay, and if we do list of the fruit collection, we get a list as well. Okay, so that's really the basic idea of what list does. Is list actually convert whatever that you have into a list. Okay, hopefully that's useful for you to understand this topic here, the range function. We also touch on list and just repeat the concept of for loop and finally enumerate. With that, I'm going to stop this video. Thank you for watching. Welcome back. Previously we covered range, enumerate as well as list. In this session we're going to go into something a little bit different. Break, continue, and else clause for loops. Okay, the learning outcomes here is really where does or how does the break statement works. Breaks all of the innermost enclosing for or while loop. Now break only works on for and while loop. Okay, keep that in mind. Alright, so we're still playing with our friend here, the fruit collection. So we're doing a for loop of the fruit collection. So if it's equal to durian, remember the break doesn't apply to if, only applies to for. If is equal to durian, print found the smelly fruit, okay, and print the actual fruit name, which is obviously if it equals to durian, that's it. Otherwise, I love this fruit. Okay, so when you actually break here, it doesn't actually break all of if. It breaks the whole for loop. Then rambutan will not be actually printed at all because we have break the for loop altogether. And there you go. We found the smelly fruit, durian, and then we stopped because we break the for loop. Notice that the break statement is related to the for statement and not the if statement. Okay, this is just to consolidate the concept here. And the other one that we want to cover here is the continue. So we're doing a for loop again, range from 2 at a step of 1 all the way and including 9. If it's remember this, okay, this is the remainder. Okay, if n the remainder of 3 is equal to 0, meaning is divisible by 3, print I found a number divisible by 3, n, and then it continues. Okay, right. This is not very obvious how it works, so let's just run this and see if it actually make any sense or not. Right, so just another number when it's 2, okay, because it doesn't fulfill the if statement, so it go and print it. And then we iterate the second time, found a number divisible by 3, print 3, and then continue to for loop. Okay, this is the part that I want to highlight. The continue basically tells the for loop to continue to iterate to the next number. The for loop to continue with the next item. Okay, and don't continue on with the print. Okay, otherwise you're going to have found a number divisible by 3 and then just another number 3. Okay, so let me show you. If we remove the continue, this is what it looks like. You will have just another number being printed straight after found a number divisible by 3. Okay, hopefully that is clear. Now that I've removed the hash, which is means comment out. Once you actually have comment out, Python will not run anything behind that comment. It will run what's before it, but not what's after it. Okay, so hopefully that's useful for you to understand how break and continue and else works in this case. Else being covered here. Okay, welcome back. Welcome back. In this session, we're going to cover the pass statement. The beauty of pass statement, it's kind of like a placeholder. You don't know what code to write, but you know you need to do some sort of branching or for loop. You put it there. Okay, you put the pass statement there. So take for example, while is obviously an endless loop. While is true, is always going to keep running. The pass here, instead of print screen or whatever, the pass there is just alright. Just pass, kind of like any game, pass, so it doesn't do anything, but it actually is a placeholder for the actual while loop to continue. So if I press return, it will just keep on running until I press Ctrl C. Okay, Ctrl C. All right, not listening to me. Okay, so I'll just break. Yep, interrupt that. Well, unfortunately, for some reason, it doesn't actually pick up my Control C. So notice that the comment here as placeholder. The other one is calculate random. Notice that we have defined the name, defined the object, but we haven't actually write the actual body of the function yet. So that's what the pass is there for, to actually just basically, well, do nothing, just as a placeholder. So let's just say we calculate. I know we haven't looked at function yet, so let's just put 1. It does nothing. Okay, absolutely nothing at all, because the body of the code is just passed. All right, so that's pretty much what I want to cover when it comes to the pass statement. Welcome back. We are going to look at defining functions in this session. As always, I provided a link here. You can actually select the link, open it up. It's basically point you to the Python documentation. The learning outcome of defining a function is to show you, first of all, what a function looks like, and second of all, how and why you will write functions. And so that you can actually understand code and also simplify your own programs as well. So the conventions about the content and formatting of document strings, which is to do with function, I'll show you in a minute. Document string sometimes is also called doc string. So let me just highlight those. The first line should always be a short, concise summary of the object's purpose. Okay, so we have a real-life example here. Let me just bring you there, just so that you can see what it looks like. Notice that, let me see. So you have define the function. Sorry, this is a bit small. So you have the define the function name, bracket, what kind of parameters that you want to enter. You have 1, 2, and then you have the double quote, double quote, double quote 3 times, and then you have this whole portion here is called a doc string, and then finally the actual code itself and return false. Okay, so this is the square function. I copied that from here just to illustrate what you can use this for. So define the square function, and then you have the input is the object, and this whole portion here is basically the doc string. Okay. This function squares the input. You have the parameters, meaning what are the input parameters. It is a float, input a number, and what is returned is actually a square float. The number is being squared. When does it ever square? Is actually under this return. So when you actually write a define function, you must actually have a return. I mean, you can leave it as a pass, then nothing gets done. But typically when you run a function, you want it to perform something and then return the actual computation or transformation back to whoever that calls it. So in this case, because it's a square function, that's the purpose of this function, you have object times object, that means it's squared. So we run that. Okay, and okay, so this pops out finally for some reason. Okay, this is the earlier enumerate that I actually call. Only now it shows up. Strange. So let me just close that. Maybe it was there all along because I zoom in, it didn't show up. Okay, never mind. Maybe you can actually play with it a little later at your own time. So this is the definition from the Python documentation. What I want to cover here, I'll put it here for completion's sake. There are a couple of things here. DEF here introduced the function definition. I usually call it define. The first statement can optionally be a string literal. This string literal is the function's document string. Sometimes people call it docstring, or docstring for short. The execution of the function introduced new symbol table used for local variables of the function. So this part here is that everything that is performed is contained within this function. So if within here I define x is equal to 2, once the function has performed its task, you will not find x anymore. X only exists within this function. Okay, so basically that's what it means by introduce a new symbol table use for the local variables of the function. So once you leave the functions, they will get destroyed. Okay. The actual parameters or arguments to a function call are introduced in the local symbol table of the call function when it's called. Okay, that sounds a massively fancy terminology. Literally, in our case, this is the OBJ. Okay, the OBJ is basically, OBJ is actually the parameters, or sometimes also called arguments. Okay, arguments are typically passed using call by value, where the value is always an object reference, not the value of the object. So meaning it is point to the memory or the location of the object rather than actual object itself. I know that's a little bit arbitrary. We'll come back to this concept a little later another time. So let's look at the actual function itself. Remember we already defined the square function earlier. So if we provide 5, okay, 5 is 25, right? So that gives us that value. So what happens if I don't actually provide anything? What do I get? I get the actual function and then underscore main underscore dot square function. All right, so it doesn't actually tell me anything except that this is a function and then it's a square function. Now, if we actually do something like this, this is called instantiation. You have instantiate, meaning made a copy of the square function. So now if I put SF bracket 4, it's square 4. All right, so you can actually make multiple instances or copies of this. What happens if I put 2 numbers? Now it gets an error. Why? Because when we actually defined this function, we were only expecting 1. Okay, so when you provide a 2, it's like, I don't know what's happening. So that's why you have this type error. Square function takes 1 positional argument, but 2 were given. It was expecting 1, you provided 2, hence you confuse it completely. Right, so let's define fib2 bracket n. This is returning the Fibonacci series up to the number n. So there you have the docstring, return a list containing the Fibonacci series up to n. We're not too worried about this part here. What we're interested in is what does the function look like. Okay, so if I want to actually create a Fibonacci number up to 100, I call this variable f100. So basically run this and assign it to f100. So let's run this. Okay, fib2 is not defined. Well, this is what happened here. Notice that there's a blank here, meaning I haven't run this cell. If I haven't defined this, this is not going to know what it is. So name error, name, fib2 is not defined. How you understand a lot of these errors is you make the mistakes, you read the error code, and then you realize what you actually did not do or did do that caused the error in the first place. And that's basically a lot of time how you learn these, basically by trial and error. Alright, looks like everything runs fine. Everything is stored on F100. Let's run F100 and we get this Fibonacci number series here all the way to 100. So some new features that we've learned here, which is quite interesting, is that the return statement returns with the value from a function. Return without an expression, arguments return 0. Okay, so which is, we saw it here, return, this part return object times object, which is the square of whatever the number that we provide. Okay, if you leave nothing there, all you're going to get is nothing. Okay, none. The statement result.append bracket a calls a method of the list object result. A method is a function that belongs to an object and is named object.methodName. Where the object is the same object, this may be an expression and method name is the name of a method. So these are like gobbledygooks. It doesn't make any sense to you. Let's look at this. Okay, let me open up. So let's just type f ib2 dot. Okay, so looks like with this there are no so-called method being attached to this. So let's try f100. Okay, with this, you notice that there are a lot of methods being attached to this variable. Okay, these are built in Python, so it's very useful. So we talked a little bit about append, or rather mentioned here. So let's just try append. Let's try 100. If we do that, and what do we get? So now we need to type f100 and see. Notice that the append meaning attach this to the end of the list. So this append is actually a method that comes with the actual list object itself. Okay, so I hope that's useful. We're going to end it here and move on to more on defining functions in the next video. Hello, welcome back. In this part, we're going to look more on defining function. This time, we're going to look at defining a function with variable number of arguments. Remember earlier we have the double the function or square function. We only allow one parameter, one argument. In this part, we're going to have variable number of arguments, meaning we don't predefine it, we allow it to have multiples. So let's look at a couple of these options here. We can start with default argument values. This is the most useful form, or it's quite useful to specify a default value for one or more arguments. So by default, there is actually already a defined value to go with it. This creates a function that can be called with fewer arguments than it is defined to allow. So let's just say define car_color, and we have defined that the color and the default value is red. So if let's define this, or define this function. So if I don't provide any color, and I'm going to get the car color is red, because that's the default value. What happens if I override the color is equal to blue, and I will get the car color being blue. So that's basically the key idea here. So note that the default values are evaluated at point of function definition in defining scope. Okay, so this is only true at the point of definition. All right, so let's just give you more examples so that you can understand what I mean here. What does this mean here? My color is equal to green. So define the watercolor and print the argument is equal to my color, which is green. Okay, print the arg, which is the argument. It should be green. That's the default color. So if I put my color is equal to orange and I run the watercolor, what happened? You would have thought that you changed the my color to orange. This will actually change to orange, but it doesn't. Okay, it doesn't because the argument, this is only looked at, or this my color is only accessed at the time that the function is defined. So it's evaluated at the point of function definition. So at the point of function definition, the color or my color is green. So this default to green, it will stay green. Doesn't matter what value you put in under my color, it will stay green forever until you destroy the definition or redefine it again. So the important warning here is this: the default value is evaluated only once. Okay, this makes a difference when the default is a mutable object, such as list, dictionary, or instances of most classes. For example, the following function accumulates the arguments passed to it on a subsequent calls. Okay, so we have defined a function a comma L is equal to an empty list, and L append A and return A. So let's print this. What do you have? You have print F1. Okay, and then you print F2. Remember, L is defined as an empty list at the beginning. And what you get here is that because this is only an empty list at the point of definition, what you get is that next time when you run it, it will not be empty again. The next time when you run it, it will not be empty again. It will not be an empty list. It will just get longer and longer and longer. And that can become a problem when you actually define it this way, and that's especially if that is not your intended consequence. So if you don't want the default to be shared between subsequent calls, you can write the function like this instead. Okay, define F, A is the input, and L is by default none. If it is none, okay, if L is actually a test, basically equals to none, L is equal to an empty list. Okay, none and empty list is very different. Empty list, it's that you define this data type to be a list. None is a data type on its own, which is none. Okay, so if the first time that when you define this function, if it is none, then we create L becomes an empty list, and we append append A to L. If, however, the next time that you run it, L is not none, then what would happen? It would just append to it. Okay? Because L is by default none, this line, this if line, will almost always gonna be called. Okay, so that's why they will be all standalone numbers by themselves. So let's move on now a little bit on keyword arguments. Functions can also be called using keyword arguments of the form kwalk. Keyword arguments equal to value. For instance, the following function define parrot A, B is equal to plant, C is equal to cat, D is equal to read. So let's run this. Okay, so we've defined a function. Printing the first argument is A, printing animals versus B, which is plant, print computer vision, comparing dogs versus C, cat, and then finally print the sky is red. So what it does here is that because B, C, and D is already predefined with the default value, okay, they become optional arguments. A, however, is compulsory. Okay, it's a required argument. So now you can actually just provide one value. Okay, So when you actually print parrot 100, meaning A becomes 100. What you will have is the first argument is 100, animal versus plant, computer vision, on it goes. And when you A is equal to 2, then what you're doing here is that you have one keyword argument, okay, which also works just fine. If you have parrot, keyword argument, A is equal to 9, B is equal to bacteria, now you have just modified the default value of B from plant to bacteria. So the first argument is 9, animals versus bacteria. Alright, so now if you put C is equal to pet, A is equal to purple, that's fine because you're using keyword arguments, although positionally they are kind of like all over the place. But it's okay because you used keyword argument. Okay, so it knows that A being, because A is equal to, it doesn't actually matter which position it comes in. Now if you put parrot 1, 2, 3 like this, it's positional, that's also fine. It will take A is equal to 1, B is equal to 2, C is equal to 3. Okay, so when we run that, 1, 2, 3, and because we didn't actually provide an input value for D, D stay as red. And if you put parent, this first will be a headache, D is equal to biscuit, then that's fine. This will be a positional argument, this will become the keyword argument. Okay, so the first is headache, the last has been changed to biscuit. Okay, the rest remain the same. Now what's left with all of these will be invalid because remember we have a compulsory argument, which is the first one. When you don't put anything, you're going to get an error. This is what it looks like. Missing one required positional argument. Okay, if you put A is equal to 6 and then a what? Okay, the computer is gonna, this program is gonna get confused. Python will be like, okay, I see that you put a keyword argument for A, but what about what? What is the second one? But you didn't actually equal to anything, so it's gonna get confused. And again, it's gonna tell you positional argument follows a keyword argument. No good. All right, so this is the first, but A is also the first, and you get duplicate value error. And again. Okay, so parrot movie is equal to La La Land, and well, we have A, B, C, D. We do not have movie as a keyword argument. You're gonna get an error. Got an unexpected keyword argument, movie. So by now you are really an expert and masters in understanding errors. You have type error, you have syntax error. By now, next time when you come across this kind of error thrown at you, hopefully you understand what they mean. Alright, in a function call, keywords argument must follow the positional arguments. This part is really, really important. So let's just highlight this. No argument may receive a value more than once. That's also another key point here. Okay, so when a final formal parameter of the form star star name is present, it receives a dictionary containing all keyword arguments except for those corresponding to a formal parameter. This may be combined to a formal parameter of the form star name, which receives tuple containing the positional arguments beyond the formal parameter list. Star name must occur before the star star name. Okay, star star name receives dictionary. Star name receives a tuple. Okay, I know that we haven't explained what is dictionary, what's tuple, but it's okay. Right? We won't worry too much about that. But for now, just look at this and understand how it works. So you have a definition here, long list. Don't worry about what all of these does. You have fruit, and you have the star tropic. Remember star tropic with the star in front, it gives the tuple. Double star, it's a dictionary. So let's just, where's our tuple? And then we have a dictionary. Okay. Okay, so because it's variable in length, okay, we do not know how long this is. So we kind of have to actually unpack it a little bit. So this is why we have this for T in tropic T. We loop over to tropic. Tropic is this input here. This happens to be a dictionary, so we can actually, it's iterable, so you can actually loop through the whole thing. And temperature, is our second one, which happens to be, sorry, this first one is actually a tuple. Tuple is also iterable, so we can actually loop through that, that's fine. We can also loop through the so-called dictionary as well. In this case, because dictionary is a key with the colon followed by the actual value itself, which is why it's displayed this way. So let's just run this. Okay, first one will be fruit. Okay, so that's the first, followed by banana, mango, and then you have two keyword arguments here. Now with this, it learns because the first one is actually a tuple. The second one, because it comes with keywords, notice that containing all keyword arguments, tuple containing the positional arguments. Okay, so this part is also very important. You must read the definition. Okay, so, and then we have the positional. And hence we have, this is the keyword, okay, which is the first one, which goes with the fruit. Fruit, this two, okay, print fruit, which is that fruit, print 40 times star, this is just a breakaway. Print information, this is star tropic, these are what's in star tropic, which is banana, mango, which is these two here because we're using the for loop. Remember, these are the tuple, and they are positional arguments because we don't have a keyword in front of it, whereby these two have keywords. Australia is the keyword, US is the keyword, but we didn't predefine the keywords, so that's why it's double star is the two keywords, and this is in star temperature. Okay, and you get this Australia, orange, and US is Sankis, whatever that means. Okay, I think we've covered a lot in this segment. We still have a little bit more to cover in terms of the arguments as well as the Lambda expressions. Let's finish this, stop this for now, and we'll come back to those last two. Welcome back. Let's look at the last two items in the arguments that we want to cover here. Unpacking argument list. We've already seen this before. You can use list to unpack a range. So 3, 4, 5 is what you're going to get. If you have argument 3 to 6 like this, you have this range. You can actually input range. Remember, this star here tells you it's a tuple. Okay, so what this will do is that it will unpack that for you into this form here. All right, so that's the beauty of using range, especially when you have numeric input like this. And also, the next thing I want to cover is lambda expression. Lambda expression is a little bit like function, except that it's very compact. If you write square root using the define function, it will look like this. But if you're using lambda, it will look like this. So you have lambda, the two so-called parameters or arguments, m, n, colon, tells the program or tells Python this is the beginning of the definition of the function. So it's m times bracket 1 over n. Well, I don't know if this is necessarily square root per se. It should be to the power. And there's more like it. Okay, so and nevertheless, what this is actually saying, lambda is you have two keyword arguments, and then you have the definition of the so-called function itself, and then store the value into square root. But in this case, because this is actually a function, we have just defined a function. So square root of 4 over 2 is 2. Okay, so this is 4 to the power 1 over 2, which is actually square root. Okay, and the other way to define this is actually use define square root underscore function, and you're doing it this way. That's the normal way you define it, and then you're going to get the same result. So that's really what I want to cover to round up arguments as well as lambda expressions. When we come back, we're going to move on to document strings and a few other key things. Welcome back. In this segment, I want to cover or go into depth on document strings, which we covered before, which is also called docstring. Just a little bit some of the standard practice here is that the first line should always be short, concise summary of the object purpose. The second line should be blank, followed by further descriptions of what the parameters and what are the output. Much of what we actually demonstrated earlier in terms of the square function. So in this case here, you have this one short line, which is the first line, should be a short, concise summary of the object's purpose, and then the other part is actually a further description of it. So in this case, it's actually a placeholder pass. So if we define this function and we run print, in order to read the docstring, you type is my func dot doubles underscore underscore dot underscore underscore. Well, these are also called dunder. Okay, dunder doc dunder. So when you print it, it actually print the actual docstring. Alright, so this is another way to do it. And what you notice that there's actually a slightly different indentation, and when you actually have it straight after the triple quote versus new line break. Okay, so that's really all. When we come back, we're going to look at coding style. Welcome back. This session really is a little bit about the actual coding style that comes with Python. It's not so much one that is about how to program. It's just the general so-called custom or the culture of the Python developers or programmers follow. Now, you are almost always going to write longer, more complex pieces of Python. It is good to talk about the actual coding styles. This helps because it creates the consistency and same standard. So that makes it easier for everyone because we all write in the same method. Now for Python, PEP8 is actually the style guide. Okay, it promotes a very readable and eye-pleasing coding style. You can actually click onto this. It will open up. It will tell you a little bit more of the actual coding style. It's quite a lengthy document. I won't go through that. I'll leave that with you. But there are some key points here which I've extracted from the document itself. Use 4-space indentation, no tabs. 4 spaces are good compromise between small indentation and larger indentation. Okay, tabs introduce a lot of confusion, are almost always best left out. Wrap the line so that they don't exceed 79 characters. Okay, this helps users with a smaller display to be able to read the code files side by side on a larger display. Use blank line to separate functions and classes and larger blocks of code inside functions. Whenever possible, put comments on the line of their own. Use docstring, we already covered that. Use spaces around operators and after commas, but not directly inside bracketing constructs. So notice that there is actually a space, but directly inside the bracket construct, there's no space. And between operators, there's also another space. Name your classes and functions consistently. The convention is usually using camel case for classes and lowercase with underscore. What does it mean by camel case? Camel case means the first letter is, well, kind of like camel, okay? You have the first letter, it's a hump, and then the middle, another hump. And basically you have lowercase, underscore, lowercase for functions and methods. Always use self as the name for the first method argument. This is class, which we will cover later. Don't use fancy encodings if your code is meant to be used in international environment. Python's default is UTF-8, or even plain ASCII works best in any case. Likewise, don't use any non-ASCII characters and identifiers if there are only the slightest chance possible people reading a different language will read or maintain the code. This is just so that we provide the lowest common denominator, the common ground, so that there isn't any confusion. So ASCII, what are they? ASCII table looks like this. So this is really the basic of ASCII table. Let me see if I can. Yeah. So these are the ASCII table, space, and then apostrophe, and all the way. Okay, you have 0, 1, 2, 3, and then capital A, B, C, D, and then small caps A, B, C, D. All right, so that's really it for this part on coding style. There are some other references for you to refer to, and that's the end. Thank you for watching. Welcome back. We're going to move into data structures, just so that we understand the different various type of data structures that's available in Python. What have we covered so far is that we've covered numbers, such as integers and floats. We covered strings. We covered list. We're going to move on from there a little bit and start looking at some other data structures that's available in Python. So some slight digression. I just want to cover some basics. We talked about and cover things like iterables, iterator. What exactly is it? I've kind of like jumped around the issue. I never really explained it in full, so I'm gonna take a bit of time to explain this. Now I found this really nice Stack Overflow. Someone asked a question, and someone actually, well, there's a couple of people that came along and actually gave the answer to that. Really love the answer they actually provided, so that's why I copy and paste some of it for your reference. This is also part of the thing that I do want to share with you, and I really want you to actually pay attention to, is that a lot of what you want to do, somebody already has already asked the question somewhere. You can find your answer in Stack Overflow, Stack Exchange. You just need to open up Google and type the questions that you have. And with some keywords, of course, it will typically bring up all the questions that, well, the answers to the questions that you have. So here you have what exactly are Python's iterator, iterable, and iteration protocols. And obviously, the public came along and gave the answer. You look for those with high ticks, 320 for this, 231 for this. So there are a couple of really good answers there. Now, I've extracted some of the key ones here, which I think is really handy. An iterable is anything that can be looped over. I.e., you can loop over a string or file or list that we actually covered previously. Or anything that can appear on the right side of a for loop, such as for x in iterable and then ... Or anything you can call with iter bracket that will return an iterator, iter bracket object, or an object that defines dunder, iter, and dunder that returns a fresh iterator, or may have a dunder get item dunder method suitable for index lookup. Now some of these are a little bit in the formal side, but nevertheless it's just a different way of explaining the fact that you can actually loop over an iterable object. Okay, what then is an iterator? Iterator is an object with state that remembers where it is during iteration. Okay, it also has a with dunder next dunder method that returns the next value in the iteration, updates the state to point at the next value, and signal when it is done by raising stop iteration. And that is self-iterable, meaning that it has an underscore or dunder iter dunder method that returns self. Note, the dunder next dunder method in Python 3 is spelled next in Python 2, and the built-in function next bracket calls that method on the object passed on to it. So that's really what's an iterable and iterator. Now, hopefully it will become a little bit clearer as we actually walk through some example. Now, what I have here is that you have an iterable. Okay, it's a string object that is immutable. There's no state, and also has a dunder get item method. So let's run this. So here we have the classic text is an iterable. Okay, an iterator, okay, has a state. It starts by pointing at the C, which is classic C in classic text. Okay, so that we know what we're talking about here. Has a next method and then dunder iter dunder method. Okay, so right, let's next gives us a C, a next gives us a classic L, next is a A, next. Okay, so this is what you call an iterator. Okay, so remember now, by now, they come back here. Iterator is an object with state that remember where it is during iteration. Okay, it has a next method that returns the next value and keep going until it's provided a stop iteration. An iterable is something that you can loop over. Okay, so here is something that you can loop over. Right, so with that, I'm going to stop. This is really a digression just to explain a little bit about the concept on iterable as well as iterator. When we come back, we're going to move on to list. Hi, welcome back. We're going to expand on what we covered earlier on list. Now we're going to go into covering some of the really useful methods that comes with list. Okay, so let's start with append. This is something that we are familiar with because we've seen it before. You have the list. I call it list here. Dot append, meaning adding a value. Okay, basically add an item to the end of the list. Okay, it is equivalent to this. So basically, you have A is the list of 1, 2, 3. When you append 4, you basically have 4 added to the end of the list. What about extend? Extend the list by appending all the items from the iterable. Okay, so right, so you have A is an iterable. So what you have here is that you have B is also a list. When you have extend, basically what you have is that you extended B with A. All right, so that's really the basic idea here. Insert is an insert item at a given position. The first argument is the index of the element, so meaning where do we want to insert this, before which to insert. So you have a.insert 0 inserts at the front of the list, and a.insert length of A is equivalent to adding it or inserting it to the end, which is the same as append. So we have B, and then we have insert at the index number 3, which is 0, 1, 2, 3, 1007. So let's have a look. So notice that at position number 3, it insert 1007 and push the rest to the back. So let's continue on. Remove here, it removed the first item from the list whose value is x. So in this case, because we specify x as the value, all right, what you will get is that it will remove that value, but it will only remove the first item. If you have 4 of the same observations, it will only remove the first one. But if it cannot find that value in the actual list itself, you will actually get an error. So let's print B. We have 1 in here, so 1 will be removed. Now what happens if we ask it to remove 7? And you're going to get an error basically telling you, hey, X is not in the list. All right. Pop is another method whereby it removes the item at a given position in the list and return it. If no index is specified, a.pop removes and returns the last item in the list. Okay. The square bracket around the I in the method signature denote that the parameter is optional, not that you should type square bracket at that position. You should see notation frequently in the Python library reference. So similar to remove, except remove a value if it's in the list. Pop here is actually pointing to a position. So you have B here, popping 2, meaning we want to remove 1007. Now it's gone. Okay, it's gone from the list B. And if it's clear, basically remove all items from the list. Okay, so it's equivalent to delete A with the column. A, it looks like this, B looks like this. Okay, and if we C is equal to A, D is equal to a copy of B. Let's have a look at C again. If we clear C, C should be nothing, empty list. What about A? A is also an empty list. It is at this point that I do want to actually highlight something. This whole exercise here is to highlight some very important point about copying. This is not really copying here. This is actually copy by reference. Okay, so what it has is actually it's pointing it to a specific location. Shallow copy. Okay, copy by reference basically means that C is not copying the value of A. C is actually, when you do this assignment here, it's just actually C is actually pointing to where A is stored. So when you actually clear C, you actually clear A at the same time as well. Right, so let's look at D. When we actually clear D, D should be empty and B will still stay the same, unchanged, because we did a shallow copy here. So this one is actually copying the value rather than copy by reference. Okay, so let's move on to index. List.index, you have the index, you have the start, you have the end here. Return a zero base index in the list of the first item whose value is x. So let's just say we have B here, right? We're trying to find what the index number that has the value 3, and what you get is actually 0, 1, 2, 3. Okay, so it tells you the index, okay, the location. Right, what about count? Count returns the number of times x appear in the list. Okay, so let's create a long list of B, and we want to count how many 11 is in B, and what you have here is 1 here and 1 here, that gives you 2. And sorting is, as the name suggests, sorting it in either ascending or descending order depending on how you define it. So let's print B first, sort, and print B again. Notice that it's from ascending order. If we want to reverse it, that becomes descending order. And reverse basically is reversing the order, and now is in the ascending order. Copy, dot copy here basically return a shallow copy of the list. We talked about that slightly earlier. So let's look at this. You have the base example, base underscore example, which is what I call it, and what you have is that it's a list of a list. Okay, list within a list. You have 7 and 5 is actually a list, right? And then you have the 3, 4, 6 is it's a list item on its own. Okay, so so what we want to do is that we are doing an assignment. So base assignment looks like this. Okay, so this is not really copying, it's actually assigning, so it's pointing to the same location. So when I actually change index 1 to 0.4, the base example will also change. Note the copy by assignment. It is pointing to the same location. When you change the copy, you are changing the original. Okay, so that's what we actually mentioned earlier, much earlier, copy by reference. Okay, so that's that. It's the same here, copy by, actually I should call it copy by assignment. Let's just maintain consistent terminology here. Okay, let's come back down. All right, here's a second example, which is a shallow copy. Okay, so assignment. Let's go back to assignment first. Assignment statement in Python do not copy objects. They merely create the bindings between the target and an object. Now, for collections that are mutable or contain mutable items, a copy is sometimes needed, so one can change one copy without changing the other, which is the case of list. So here we have a shallow copy. Okay, so if I change the index, the value of index 1 to 3991, the copy will change, but the original copy will not. Okay, note that due to shallow copy, the original data was not affected. This is still a problem though. The problem arises when you try to change the list. The list is within the list itself. If I actually change this number here to 999.99, the base example will still be changed as well. So in this situation, we will need to perform deep copy. So from copy, import deep copy, and we perform this deep copy of the base example and save it to this value, which we call base underscore deep copy. And when we actually do change the second, the index 1, the base doesn't change. And when we actually do change the number within the list, it doesn't change as well. Okay, I hope that has been useful. We've covered a lot of some of the features that comes with list. There's still a little bit more to go through. For now, let's stop here. We'll come back to that a little later. Welcome. Using list as a stacks. The list method so far makes it easy to use list as a stack where the last element added is the first element being retrieved, which is what's also called LIFO, last in, first out. To add an item to the top of the stack, we use append. To retrieve an item from the top of the stack, we use pop without an explicit index. So let's look at an example. So this is last in, first out. We have 2, 3, 4, 5. If we append 3.14 to the end of it, if we want to remove it, just use the method called pop. That will remove the last item. So that's essentially, you have append to add to the top of the stack, pop to remove it from the top of the stack as well. You can also use lists as a queue. It is also possible to use lists as a queue where the first element added is the first element retrieved, also what we call first in, first out. However, lists are not efficient for this purpose. So typically, we use a different method. Okay, so to implement a queue, we use collections.deki. Okay, I'm not too sure how you pronounce this, which was designed to have fast appends and pops from both ends. So let's import from collections. We import deck. The name list here is John, Michael, Bruce, and Abby. First in, first out, we deck the name list. Okay, so that FIFO is there, and if we pop left, John pops out, and if we look at the value again, you have that. So you can actually pop right, which Abby will come out, pop left will be John that comes out. So that's actually a very fast and efficient method for using list as a queue. So with that, I'm going to stop. List comprehension is quite a long topic and a very interesting one though. So we're going to leave that to the next video. Hi, welcome back. We're going to move into list comprehensions, a really interesting and fascinating topic. Now, list comprehension provides a really concise way to create a list. So let's look into that. There are 3 ways, essentially, to create a list of cubes. You can use the normal method, which is using for loop for n in range 0 to 10, not including 10 cubes. And then you append to the value cubes, which will actually create a list here, append n times n times n, okay, and print cubes. Right, so let's just run that, and this is the value. Another method is actually to use the lambda function. Lambda, the argument x is equal to x times x times x. What is x? Is actually the range of 10. Basically, you are mapping the range of 10 to x and then convert it to a list. And when you run that, it's exactly the same. The method number 3 is list comprehension. So is x times, basically this is x cubed, for x in the range 0 to 10. So this is actually list comprehension. You can see that this is actually quite attractive because it's short, it's sweet, and also it gets the job done as well. Alright, so that's what really quite exciting about this. If you're using for loop, looking at the combinations of Jimmy, Audrey, and Ono, so let's just say for student 1 in class 1, and then for student 2 in class 2, if student 1 is not equal to student 2, then combinations append student 1, student 2. Okay, so this is actually iterating through. You start with for class 1 is this one here, so you have for first one is Jimmy. Okay, so that's right now is Jimmy, student 1 is Jimmy. So for student 2 in class 1, if and then you do, let's just say the class 1 first one is also Jimmy. If student 1 is not equal to student 2, not equal, then you append. If it's equal, then we go back, fetch Audrey. Okay, then you have Jimmy and Audrey. again, then Jimmy and Ono, and then you come back. All right, because we already finished through the end of the list. Come back, fetch the second one, which is Audrey, and on it go. Okay, so that's what you have: Jimmy, Audrey, Jimmy, Ono, and then on it goes. So if you take this same line of codes and you convert it to list comprehensions, this is what it looks like. A little bit messy, seems to be a little bit messy, but essentially it's the same core idea. This whole part here for student 1 in class 1, okay, is the same as for student 1 in class 1, and then you for student 2 in class 1, which again is the same one here, and then you have the if statement, okay, and then finally you have these combinations here. Notice that it is actually very concise. It's just one line versus the multiple lines here. To look at more example of list comprehension, you can have range -4 to 8 with a step of 2 and converting it to a list. So that's one way. If you want to double the number, excuse me, x to the power 2 for x in x underscore train. So basically you have square, 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 all of these. Applying absolute value, which is the same as this, and this is what you actually get here. Now if you look at these list of dog names, if you want to actually remove, for example, some of the empty spaces, okay, that's what the strip does, is to actually remove the empty space. So what you have is that the space has been removed. What you have now is that American Bulldog without the space, Berger Picard, Bull Mastiff, Collie, and Harrier. And the other method here, notice that we do have some commas here that we do want to remove. You can loop through and make use of a method to remove the actual comma. Okay, so now that it's cleaned up, it has removed the comma, however you still have the space. Okay, so because we are working on the Y train as well, so essentially this is for Y in Y train, we're looping through these. For the value of Y, we're doing strip of the comma. This one is loop through the Y train. For the Y, we strip off any empty space. So now we want to do both. So this is what you do. Again, when you loop through, you do the strip and then you convert it into uppercase, and you also you removed the actual empty space, you also remove the comma. And that basically clean up everything for us. Okay, so we have a list in list. How do we unpack this list in list? You can actually make use of a for loop, such as this. Okay, that does it. The alternative is to use a for loop for num in list, and for n in num. Excuse me. How does this work? So first thing, you loop through the num in the list. Okay, so you're looping through all of these. Okay, what do we have? We have a list of 3, 0, 1, 2. Okay, and the other thing is that for num, for n is num, n in num, which is the 0, 1, 2, 0, 1, 2, 0, 1, 2. And for this n, we actually have it standalone by itself. Okay, so essentially this works a little bit like this, but it actually unpack it in a slightly different manner. That's really list comprehension for you. And just want to cover nested list comprehension before we move on. So we stored it in the matrix. This is what the matrix looks like. This is actually very similar to the this list and list that we just did. We have the row for row in matrix, so we have 0, 1, 2 row here, and then for I in the range of 4, okay, which is 1, 2, 3, 4. So basically what you are doing here is that you are actually unpacking the whole thing. Alright, so you actually tidy it in a manner that actually so that you go 1, 5, 9, and then 2, 6, 10, and then 3, 7, 11. Okay, so let's just stop this here for a second. Um, I'm not too sure if you see the actual construct here. So this starts with for I in range 4. Remember, range is 0, 1, 2, 3, okay, because it's range 4. So we start with I is equal to 0. Now that I is 0, we feed I is equal to 0 in here. And we are running for row in matrix. Okay, so in the row in matrix is 0, 1, 2. Okay, so we are starting with row 0, which is that row there. We get a row there. And then row I is 0, because we're still here, 0. So we have 1, 5, 9. Follow? Okay, because we're iterating through the row. And then next time we iterate through the row again, I has been incremented to 1, which is 2, 6, 10. And then I becomes 2, 3, 7, 11. Okay, so that's really the basic idea here. Of course, this is quite a messy way of doing it. After a while, it gets a bit complex reading the list comprehension, and quite often people use this zip function, which actually does a great job for this whole thing that we actually just did here, except that it's a tuple instead of a list. But nevertheless, it is actually fantastic for that. Recall that this asterisk here, this is from our previous lesson, that we did cover this. We'll cover this in the form of keyword and also tuple. So let me refresh your memory here. Unpacking the argument list, which is this one here. Asterisk name which receives a tuple containing the positional arguments beyond the formal parameters. So asterisk, basically we are looking at the positional. The positional here is 0, 1, 2, 3. And then zip is combining 159 and then 2, 6, 10, so, and then converting it into list. That's the basic idea here. So if you want to know more about unpacking argument list, you can look up these links that I've provided here. So when we come back, we will, let me just finish, let's finish off the delete statement so that we can actually look at tuples separately. There is a way to remove an item from a list given its index instead of its value, which is using the delete statement. So let's look at this. We have a cat list. We can delete cat's list 2, 0, 1, 2. Okay, and when you look at the cat list again, what you have is Javanese, Egyptian. Oh, the Persian is gone. All right, so if you delete the cat list 2 onwards, okay, that basically means that the whole lot disappear. From 0, 1, 2 onwards, it's gone. So if you delete cat list, basically the whole cat list is deleted, is no longer defined. Okay, that means it's completely gone. Now this differs from the pop method, which returns a value. The delete statement can also be used to remove slices from a list. Okay, the delete basically deleted. Pop actually returns a value. So therein lies the difference between the two. With that, I'm going to stop right now. There's a lot of concepts we've gone through, and when we come back, we'll go through tuples and sequences. Welcome back. In this session, we're going to cover tuples as well as sequences. We saw that lists and strings have many common properties such as indexing as well as slicing operations. They are basically an example of sequence data types. Do refer to this list if you like, or this link if you like. Now Python is an evolving language. Other sequence data types may be added in the future. There's also another standard sequence data types which is called tuple. Now tuple consists of a number of values separated by a comma. Now the example of this, remember we use type bracket whatever the variable is to check what it is. So here you have, this is actually a tuple. Now again, you can actually do indexing. That gives you 12.54. Notice that tuple has a bracket to it. Tuples may be nested as well. That's where now you have U as the actual tuple. Tuples are actually immutable, so that means you cannot change the value, much like string. Hence you actually have a type error here. It does not support items assignment, but they can contain mutable objects. Okay, so V here is actually a list, and notice that V is not a list, sorry. Inside here is actually a list. Okay, 2, 3, 4 is a list, 6, 7, 8 is a list, but the bracket means that the V is actually a tuple. From what you can see here is that an output tuple are always enclosed in parentheses, so that nested tuples are interpreted correctly. They may be input with or without surrounding parentheses, although often parentheses are necessary anyway. It is not possible to assign to the individual items of a tuple. However, it is possible to create a tuple which contain mutable objects such as list, which is what we did here. We created a tuple with mutable objects which are list. Now, tuple may look similar to list. They're often used in different situations and for different purposes. Tuples are immutables and usually contain heterogeneous sequence of elements that are accessed via unpacking or indexing. Lists are mutable and their elements are usually homogeneous and are accessed by iterating over the list. Notice therein lies the actual key difference. Tuples are typically, because it's immutable, they are accessed via, and they are often heterogeneous, meaning they have different types of data types, and usually you access it by unpacking or indexing. That's one. Lists are mutable and elements are usually accessed by iteration. A special problem is the construction of tuple containing 0 or 1 item. The syntax has some extra quirks. So empty tuples are constructed by an empty pair of parentheses. A tuple with 1 item is constructed by following a value with a comma. So it's kind of weird. It is not sufficient to enclose a single value in parentheses. Ugly, but effective. So if you're creating an empty tuple, you just use the bracket, so that's fine. But if you try to do this, this is not a tuple. Okay, it's just not a tuple. But if you put a comma, it's fine. Okay, so it's perfectly fine. So this should actually technically be over here. 1, 2, 3, 4. Okay, the statement, this is an example of tuple packing. The values, these are packed together in a tuple. The reverse equation or operation is possible. Basically, you have x, y, z, unpacking it, and you have the first stored to x, second value stored to z, the last value stored to z. Okay, so this has become x, this becomes y, this becomes z by unpacking it this way. This is called, appropriately enough, sequence unpacking and works for any sequence on the right hand side. Sequence unpacking requires that there are as many variables on the left side of the equal signs as there are elements in the sequence. So that means the number of variables on the left must equal to the number of elements, otherwise you're going to get an error. Okay, note that multiple assignment is really just a combination of tuple packing and sequence unpacking. Right, so with that I'm going to stop. In the next video we're going to go into sets. Hello, we're going to go into sets. Python also included a data type for sets. What is a set? A set is an unordered collection with no duplicate elements. So it's very similar to math that you learn in high school as well. The basic use includes membership testing and eliminating duplicate entries. Okay, set objects also support mathematical operations like union, intersect, difference, and symmetric difference. Okay, so let's look at this. Curly braces or the set function can be used to create sets. Okay, curly bracket. So what we have here is a shopping list. So notice that there's some repeat. So let's just do this. And then we have 8 items in this shopping list. Some of them are actually repeated. Notice that if we actually do what you call a curly bracket, the length actually shortens. right? We can of course copy and paste this whole thing and put it here, and still 4 items. Okay, notice that that actually remove all duplicates. Sometimes what you can do is actually do a test. Is MacBook in shopping list? The answer is true. Is MacBook in shopping list with the small b? The answer will be no. Okay, it's actually case sensitive. Right. So what you have here is that the set, okay, reduced these. There are some duplicates. You can see Q is repeated a couple of times, E is repeated a couple of times, A is repeated a couple of times. It just basically gives you unique letters in X. These are unique letters in Y's. Okay, so there are a couple of operations you can do with this. You can have X minus Y, which is letters in X but not in Y, and you get this. Letters in both X or Y or both, and what you get is this. Letters in both X and Y, this is basically what you call an intercept. And finally, X caret Y means letters in X or Y but not both. There you come with the O P as well. So similar to list comprehension, set comprehension are also supported, but we won't be covering in this lesson. Alright, we've encountered dictionaries before, but we never really go into depth. So let's dive in and understand how dictionary actually works. Unlike sequences, which are indexed by a range of numbers, dictionary are indexed by keys, which can be any immutable types. Strings and numbers can always be keys. Tuple can be used as keys if contain only strings, number, or tuples. If a tuples contain any immutable objects, either directly or indirectly, it cannot be used as key. So with that, best to actually look at this one more definition here. It's best to think of a dictionary as an unordered set of key and value pairs. Okay, so once you actually see the example, it'll be easier to understand. So we might come back to revisit this. So this is what you call a dictionary. You have the key, which is Jim, and 1550 is the number associated with Jim, and Bob is another key. 1010 is the actual value that goes with Bob. So we store that. Let's do one more line here. So let's do type customer information, and you notice that it comes through as dictionary. So if we want to look up, here we actually want to save Lisa into the dictionary. Now we have 3 customers. If we want to delete customer information Jim, Jim is no longer in the list. If we add another customer's information, which is Liz, it will also be added as well. If we want to look for the different keys, you can actually use customer underscore info, which is the variable name, to access the keys by dot keys bracket, and will give you the 3 keys, which is Bob, Lisa, and Liz. And you can test whether Liz is in the customer information by just simply is Jim in? The answer will also be given back. Now you can actually use the DICT constructor to build dictionary directly from sequence of key value pairs. This is the key, this is the value. You can actually construct it this way. In addition, DICT or dictionary comprehension can be used to create dictionaries from arbitrary key and value expression. So we have a so-called comprehension here. This is a dictionary comprehension. So we're looking at range 10 to 16 step of 2. X is the actual value that's unpacking from this. We're using a for loop here. So you have a key. The key is X, and then the value is X to the power of 3. So that you have the key and then the X to the power value of 3. When the keys are simple strings, it's sometimes easier to specify a pair using keyword arguments such as this. You have the dictionary, the keyword arguments, and then the value, keyword arguments, and the value, especially if these are simple strings. Okay, so that basically is what it looks like. So let's look at looping techniques as well that comes with a dictionary. When looping through dictionaries, the key and corresponding value can be retrieved at the same time using the items methods. Okay, so let's look at this scale dictionary here. Scale small is S, large is L. So you have key and value in scale dot items. Okay, so basically what you have now is that you have the key is small, the value is capital S, and on it goes. To loop over two or more sequences at the same time, the entries can be paired with the zip function. So what we're doing here is that we are zipping Apple and IBM using basically the function called zip, and then for the two stock, the stock price 1, stock price 2, or stock 1, stock 2, and then you're printing them out this way. To loop over a sequence in reversed, we just basically need to use the key called reverse, and when we do that, we're just printing the numbers backwards. To loop over a sequence in sorted order, use the sorted function, which returns a new sorted list. You have this list here. Set to reduce or just cut it down, and then sorted to order it in alphabetical order. Now sometimes it's tempting to change a list while you are looping over it. However, it is often simpler and safer to create a new list instead. You have import math here. These are the raw number. We're creating an empty list called future data. So for value in raw data, if not math is not a number value, okay, then future data append the value. If not, meaning if it's not a number, if it's not a number, okay, meaning it is a valid number, then append the value. So there you have the value with the not a number removed altogether. Okay, so let me just stop here. We will come on to conditions. We cover dictionary and also the looping techniques. Pretty much the looping technique is actually standalone, but it covers a little bit of the dictionary. It's useful to know. So let's move on from that, and we'll go on to conditions a little later. Hi, welcome back. We want to actually expand a little bit on condition. The conditions used in while and if statements can contain any operators. So let me just make sure this formatting is correct. Can contain any operators, not just comparison. Comparison is greater, smaller, equal, not equal, things like that we talked about. It can also contain operators. What are the operators? We've seen some of these. In, not in. Okay, the other one is or not, is not comparison. Now the other thing is that comparison can be chained. For example, A is smaller than B, but it's also equal to C. Test whether A is less than B, and then moreover is B equal to C. You can also combine using the Boolean operators and or, and the outcome of the comparison may be negated with a not. Okay, so there are actually a lot of combinations that you can do with this. So let's just look at some example. So we're unpacking this to string 1, 2, 3. String 1 or string 2 or string 3 is not null. Okay, so if you print that out, what you have here is that you actually have an OR operation. Okay, what exactly is an OR operation? The Boolean operators and or are so-called short-circuit operators. The arguments are evaluated from left to right, and evaluation stops as soon as the outcome is determined. Now, for example, A and C are true, but B is false. A and B and C does not evaluate the expression C at all. So basically, when you actually start from left to right, once A and B is true, all right, then done. Okay, we're not going to look at C at all. So when used as a general value, not as Boolean, the return value of a short circuit operator is the last evaluated argument. So if you look at this, we're storing anything not now, basically not a now number, string 1 or string 2. Okay, now string 1 is empty, but when you have a or string 2 is true, then basically only string 2 will be stored, and it won't even test the next one at all, and string 2 will be stored here. Okay, let's stop there, and we'll come back to comparing sequences and other types later. Hi, welcome back. Let's understand one of the key concepts about comparing sequences and other types. Now, from time to time, you do need to make comparison. Sequence objects may be compared to other objects with the same sequence type. The method that's being used is what you call lexicographical ordering. You compare first and first, second and second, third and third, and on it goes. What you have here is that the first two items are compared, and if they differ, this determines the outcome of the comparisons. If they're equal, the next two items are compared, and so on, until either sequence is exhausted. Now, if two items to be compared are themselves sequence of the same type, the lexicographical comparison is carried out recursively, meaning repeatedly. If all items of the two sequence compared equal, the sequence are considered equal. If one sequence is initial subsequence of the other, the shorter sequence is the smaller one. Alright, so let's have a look at this. So 1, 2, 3 is smaller than 1, 2, 4. Okay, so and it obviously is true. 1, 1, okay, and on it goes. So what about this? And the answer is also true. Okay, so what about this? A, B, C, C, Pascal, Python, and what you get is actually true. This is smaller than this, which is smaller than this, which is smaller than this. Okay, and this is the interesting one. Is it true or false? Take a moment, take a deep breath, think about it a little bit, and I'm going to show you the answer now. And the answer actually is true. Okay, it's true because it's 1 compared to 1. Remember the actual algorithm here. The first two items are compared. 1, 2 compared to 1, 2. All right, they are the same, so the next two items are compared. 3, 4 compared to 4, okay, 4 something. But because the 3 is smaller than 4, it's true. How about this? This is the interesting one. Okay, so 1, 2, 1, 2. Let's look at the actual explanation here. So if two items are comparing themselves, where is it? Where's the exhaust one? Until either sequence is exhausted. Well, it doesn't actually say, right? So how do you compare when it's actually one is exhausted, the other one's not? So let's have a look. The answer happens to be true. True because this has more and this has less. Okay, what about this? Are they equal? Well, this is, as we know, these are integer, these are float, and is it actually so-called sensitive? And turns out that it is. It understands. It actually can compare integer to float. What about this? This is an interesting one. 1, 2, 1, 2. The next two is A, B, C, A. And it looks like that this is smaller. Is that true or false? Let's run this and have a look. It turns out that it is true. Okay, my interpretation of this might be wrong. Okay, but satisfy yourself that, well, at least you know that Python is not going to make a mistakes, right? So know that comparing objects of different types, smaller or larger, is legal, provided that the objects have appropriate comparison methods. For example, mixed numerical types are compared according to their numeric value, so 0 equals to 0.0, etc. Otherwise, rather than providing an arbitrary ordering, the interpreter would raise a type error exception. I think one of the key things is when you're actually writing the code that requires this kind of comparison, do test it. That's one of the beauty of Python, is that you can actually test it right there and then, just to see what kind of behavior you're going to get, and is it consistent. That part is really important. With that, I'm going to stop, and that's the end of this lesson on data structures. Thank you. Welcome back. In this segment, we're going to go into modules. Now, if you quit from the Python interpreter and enter again, what would happen is that everything that you would have done and enter in either in the IDE, Integrated Development Environment, or the Jupyter Notebook, it'll be gone. Meaning the definitions that you made, be it the functions, the variables, they'll be all lost. So that means you have to start all over again. So therefore, if you want to write something of longer in nature, something that is permanent, then you would naturally gravitate towards using a text editor to write what is called a script. All right, so in this segment, we're going to show you how you can write the script and that you can actually regularly pull it up and make use of it again and again. And quite often, you will write your program in a modular manner, hence the term modules, so that it's actually modular in nature, it's small, it's readable, it's not ultra long, which makes it really difficult to manage and also maintain. Right, so to support this, Python has a way to put definition in a file and use them in a script or in each interactive instance of the interpreter. So it provided this method which allows you to actually make use of it in a script manner. And all of these can be brought in via this command called import. And you've seen import a few times. So we're going to show you how what it is, and also how to make use of it at the same time. Okay, definition from a module can be imported into other modules or into the main module. Okay, the main module is the collection of variables that you have access to in a script executed at the top level and in calculator mode. So meaning that's really the variables that you've been utilizing all along. So what is a module? A module really is a file containing Python definitions and statements. The file name is the module name with the suffix .py. So it's a little bit different from all the modules or the codes that we've been using. What we've been using has the, let me just zoom in, .pynb. So it's a little bit different, okay? These .py here will be example of modules, okay? Right. Now within a module, the module's name, often as a string, is available as the value of the global variable dunder, name dunder. For instance, you use your favorite text editor to create a file called feeble.py in the current directory with the following contents. So it looks like this. Notice that the file name is called feeble.py and there are two definitions in there. One is fib, the other one is fib2. What does fib1 do, or the fib do? It writes Fibonacci series up to n. What does fib2 do? It returns Fibonacci series up to n. Okay, so there is, well, we'll write it out and so that you can actually see what it looks like. One writes it on the screen, the other one actually returns the series. Alright, so we're going to run these. Now, I just want to show you too that the feeble, I've already pre-written it and I've also placed it in the so-called notebook Azure, this cloud, so you can actually immediately make use of it. But let's just see if we can actually view the file, preview it, the content. Alright, so you can see that this content is exactly the same as this content here, and I've already pre-written it for you. Okay, so let's go back to the library, Python, and let's go into running these codes. So we first of all want to import feeble, okay, because we need to import this, otherwise nothing will run because we haven't imported these scripts into the system yet. So import feeble. All right, first thing is imported. The one thing that you do need to be very careful of is you need to make sure this script is in the directory that you are running, otherwise you will encounter error. Now, this does not enter the names of the functions defined in Feeble directly in the current symbol table. It only enters the module name Feeble here. Using the module names, you can access the actual functions that's defined within Feeble itself. So looking at this, you have feeble.fib right up to 1000. So this is accessing the first definition, okay, the function within the feeble.py. When you import, you don't need to type .py, that's actually given. Okay, so then you can actually access fib2, which is that one there, by dot notation followed by the function name, and you can put 100 here. And finally, feeble dunder name dunder will actually print out the name itself. So let's just run this. Okay, so what you can see here is that what we do want to do is just print these actually so that you can actually see the output, because otherwise you can't really tell. In fact, what I will do is that I'm best to write these individually themselves. Up to 1000, this is what it looks like. And if I do this one, you will not get an output. Oh, you do get an output. Well, you will get an output because I didn't put a variable in front of it. And finally, okay, the name itself is actually Feeble. Okay, so that's the three key things here that we wanted to actually show. One is .fib, it's 1000. This print to screen. So if you put an A in front, okay, it will still print to screen. And do you get anything for A? Actually nothing, because remember there was no return here. Okay, unlike function number 2, it does have a return. So if I now change B is equal to that, they won't print on screen because we don't have a print, okay, within the definition of fib2. Instead, it will be stored because the value is being returned. It will be stored in B, and when we actually type B, you get the results come onto the screen here. Now, if you intend to use a function often, you can assign it to a local name, okay, and by doing it this way, fib is equal to feeble.fib, and that would actually give you the name in the local main memory that allows you to actually access it anytime. Okay, so that's really a quick and gentle introduction to modules, the rationale of modules, how you make use of modules, and how do you actually utilize it. I hope that has been useful for you. Welcome back. As an extension to what we covered in the previous lesson on modules, I just want to show you how you actually write a .py file. Now, for a .py file, you will not be able to actually make use of this, the actual Azure Notebooks .Azure Cloud Services, because the Azure right now is only designed for notebooks or Jupyter notebooks. So we're going to turn over and come over to this Spider, which is a distribution of Anaconda. This basically is an integrated development environment, but we're going to use it just more like what you would call it, more like a text editor rather than using it as a development environment. So we're going to write a program. We're going to have a couple of really straightforward terminology and definitions in here. First of all, we'll just write A is equal to 10. So this module will have its own so-called local variable, and we're going to define result, okay, without any input. B is equal to 2. Okay, and then we're going to write another function, define, and this time we're going to define function. Okay, this time with an input we'll call it object, and object times object. Okay, and we're going to return this, and we're going to return B as well. With a slight variation, we're going to print B as well onto the screen. Okay, so looking at this, there's a couple of things that we've done here. Is that we have, number one, attributes or value that comes with the actual file itself. That's the first thing. Second thing is that we have two functions defined. Define res, where b is equal to 2, and then we print b onto the screen as well as return b as well. And also define a function which takes in an argument or keyword, and then we return the square of the actual argument itself. Now I'm going to save this and saved it onto my desktop, Python, and folder scripts, and I'm going to call this file test.py and save it. And if I look at the file explorer, you will be able to see that this file is indeed here. So let's come over to let's see. Yep, come over to a terminal. Okay. Yep, we can zoom in. Okay, so within the terminal, okay. So if I list the files in here, you can see that there is the file called test.py. I am in the same directory as this, which is desktop Python script. So remember what I mentioned earlier in the previous lesson. You must make sure that when you're writing this script, the file is, or the modules that you're trying to access is in the same directory. If it's in a different directory, you can access it differently. We'll show you another time. So let's run an IPython. Okay, and all right. So this is basically the IPython interface, and we're going to import test. Okay, all right. Okay, that means the import has come through successfully. So if I type A, I don't actually have any value because A is not defined. So if I type test dot, okay, dot notation and type tab, notice that a few options come up. And notice that they are actually very similar to, well, in fact, they are exactly the same as what we have defined here. So A, if I press enter now, I get the value 10. So that's really how you actually import the module and you access the actual predefined functions, variables in the actual module itself. Now, previously, before we import, if I just put reset, this will delete everything. A is not there. Okay. And if I write test dot and tab, nothing will come up. Okay, only putting in the .py there. Okay, so that's really one of the key things that I really want to highlight to you. So let's just import test again. We want to continue with this experiment. Let me clear the screen. Okay, so test dot, all right, what are the options available? Okay, there is rest. So let's type rest. Let's see what happens if we don't put the bracket. You get function test, okay, this output that you can't understand. So that is telling you you've just accessed an object. In order to access it properly, you do need to actually provide the bracket, which gives you return a value of 2, which is what we actually have defined here. Accessing rest, where we define b is equal to 2 when you print, and also print b on the screen, and you actually have the value b here. What about function? Okay, do we do likewise? Okay, you can actually do this, right? It doesn't actually have any doc string. Okay, that's the reason why we should actually provide a doc string to write it properly. So if we put fn, since we didn't provide any definitions, the user is going to be no choice but to do it by trial and error. So if we do this and you get an error, it's asking for one positional argument or object. So that means we need to actually provide it with an object. So let's try 2. And what is returned is 2 to the power of 2, which is 4. Let's try that, because we don't, assuming you don't have access to the actual source code, you don't know what that is, you would not know this is actually the function, what this function actually perform, what role does it perform. You got no choice but to actually do it trial and error. The docstring also doesn't actually tell you much as well. And that, in essence, is what I wanted to show you, how you can actually make use of this by still using a Python interpreter, but this time a no-frills one, which is IPython, rather than using the notebooks or using Jupyter. So let's just quit this. Now we back onto the basically the terminal or command line if you're using Windows. So the file is still test.py, except now there is actually this under PyCache here. So let's just run Python test.py. Now this is one way, or another way, that you can actually run the scripts on the command line itself. What do you think will happen? Very good. Nothing. Nothing, because we didn't write anything that's going to give you an output onto the screen. But while the program is running, it will definitely have A being created, the two functions also created as well. So let's just try that out. Nothing. Okay, as expected. So what happens if I actually come down here and I type print A and also print okay, and save this and come back to this and run it again. Voila. So what we get is we get 10, which is printing A, and 2, which is when you actually run the res function, you get the print B, and then return B because you are printing the actual returns, what comes back from res. Right, let's just try one more. Print function with 6, save this once again, and run this for one last time. And there you go. You have this initial 3 output plus 36 here. Okay, so that's really a very, very quick walkthrough and really an appreciation exercise to help you to appreciate how useful the module function is and how you can run it from your command line or using IPython, the interpreter. Right, let's continue on modules. A module can contain executable statements, which you have briefly looked at earlier, as well as function and definitions. When I was actually going through the exercise earlier, I showed you how you can actually print directly to the screen. And we also defined 2 functions earlier. Within the fibbo, there is fib and also fib2. Within the .py itself, the test.py, we have defined a function which is basically b is equal to 2, and also define a square function which we call fn. Those are functions definitions. Now these statements are intended to initialize the module. They are executed only the first time the module name is encountered in an import statement. Now each module has its own private symbol table. Symbol here refer to the variables that you define within the actual module itself, which is used as the global symbol table by all functions defined in the module. Therefore, the author of a module can use global variables in the module without worrying about the accidental clashes with the user's global variables. Now these are all very fancy words. It's just being thrown around. So let me just explain a little bit for you. Now, every time when you import a module, the symbols that is defined within the actual file itself is within the so-called space of the module. So let's come over to our fibbo here. Let me just open that up. Preview. Okay, I wanted to open a new. Okay, so when you're looking at this, when you import fibbo, what would happen is that these symbols, fib and fib2, are defined, and as well as AB, all these, in particular fib and fib2, is defined within the file called fibbo. Even when you import it, it's still an attribute or modules or functions within fibbo. Okay, let's just say you have your own defined function called pi, which is 3.14. Now within Python itself, assuming it has another defined constant called pi, what would happen is that as you import it, they will clash. You will override what is defined in the global variable, and that is actually not a good situation. But in this case, because Python takes care of it, you don't have to worry about it. How does it take care of it? In order for you to access what is defined within the module, you have to first provide the module name and then the dot notation followed by the name of the variable. So in the case of fibor here, to access fib, you need to type fibor.fib. That way, it's actually clear. All these so-called symbol comes from fibor that you've imported. All right, modules can also import other modules. It is customary but not required to place all import statements at the beginning of a module, just so that it's easier and tidy, so that it's easy to actually be referred to. Let's continue on this part here, which I didn't mention. On the other hand, if you know what you are doing, you can touch a module's global variables within the same notation used to refer to its function, such as module name dot the item name. Now there is a variant of the import statement that imports names from module directly from the importing module symbol table. This is the notation, this is the method here. So it's from fibor, you import fib and fib2. When you import it using this method, what would happen is that fib and fib2 will be part of the so-called global names now. Okay, it will override whatever that you have in existence already. So just be mindful of that when you actually do that. But typically, for most part, most people will just import fibor rather than from fibor import everything inside. This does not introduce the module name from which the imports are taken in the local table. So in the example, fibor is not defined. There is even a variant to import all names that a module is defined. So one of the ways to import all the names that is defined within the so-called within the fibor module, this is how you can do it. From fibor import star, the star here means import everything. Okay, when you do this, everything will be imported. Okay, and they become local. So what does this do? This import all the names except those beginning with the underscore. In most cases, Python programmers do not use this facility since it introduces an unknown set of names into the interpreter, possibly hiding some things you've already defined. So that's the danger of doing it. Unless you know what you're doing, typically this is not a common practice. For efficiency reasons, each module is only imported once per interpreter session. Therefore, if you change your modules, you must restart the interpreter. Or if it's just one module you want to test interactively, use import lib.reload. Okay, so that's one of the key things here is that it is only imported once. Okay, so basically with that, I'm going to stop. This is a little bit more on modules. We've experienced it in the last 2 lessons. This is just really just solidify some of the learning. When we come back, we'll talk a little bit about executing modules as scripts. Welcome back. In this segment, we're going to look at executing modules as scripts. Now, when you run a Python modules with Python fibor within arguments, the code in the module will be executed just as you imported it, but with the dunder name dunder set to dunder main dunder. That means that by adding this code at the end of your module, which is this, you can make the file usable as a script as well as importable module, because the code that passes the command line only runs if the module is executed as the main file. Now, what does that actually mean? So let's look at an example here. Let's see if I can actually bring up the terminal. Okay, so let's look at this and we magnify this. Okay, so let's move to desktop, Python, and then scripts. That's where I store. Where is it? cds sc routes. Okay, so everything is there. All right, the file is actually here. So let's just run Fireball. Now, before we actually run this, let's understand what we're going to execute first of all before we run it. If you look at this, right, we have two defined functions. When you run it, nothing will happen because number one, they are both defined, but we did not activate them. So let's enter nothing. Okay, so what if I put Python fireball.py and I put, okay, 50. Again, nothing happened. Nothing happened because the function is defined and the 50 here, well, the program does not know where to actually put the 52. Hence the reason we have this line of code here that you can actually make use of. So let's just copy this. Copy this. The suggestion here is put it at the back. All right, so let's zoom this. Now, when you actually put a line like this, if dunder name dunder equals to main, what this is actually saying is that when you are writing, executing the scripts, all right, like what we actually were talking about here, executing the script, all right, as the main file, because we are running this as the main file, it will import this function called sys, and then it will take the argument, okay, the first argument that is being provided. Okay, this is index number 1, 0 is the actual name itself. It will take the argument, first argument, and it will run fib, which is this function here. So let's save this and run it and see what happens. So we run it with 50. Okay, notice that indeed fib is being run. Okay, with the so-called 50 is being provided. Okay, so that's the important part here. So what if I actually have another defined function, calculate, or just add num, and we have another input here called object, and then we have object plus 2. Okay, let's just return these. And now instead of this, I'll hashtag it. And we have add num, and we have sys arg v, and we take the first. Okay, let's save this and see what happened. Okay. Okay, so we get this error. Error because it says must be string, not integer. Or we get a type error. So we do need to convert this. Okay, and put another bracket at the end, save this and run this again. And well, what happened? Actually, it ran, but the only problem is that it ran this code but never print. Okay, so what we do here is just print object plus 2. We also return it. Okay, so now let's run it one more time and we get 52. Okay, so what have we done? What we've done here is that there are two things. One is that if you import fiball, right, then you will be able to access it by typing fiball.fib, and that will allow you to access the so-called function built within. But if you want to actually run the fiball as a main script, right, meaning a standalone file as I did here, which is this one here, let me just clear the screen. If I want to run it as a standalone as the main file, I do need to actually have this if dunder name dunder equals to main, so that it actually can be run as a main file with the so-called input arguments being accepted and associated with the functions that you want to run. Notice that whatever we define here is actually going to be the so-called functions that get run. Okay, so that's the important part. All right, so that's really what I want to cover here in terms of executing modules as scripts. When we come back, we'll go into the module search path. Hi, welcome back. One of the things that we do need to remember, because you are doing a lot of importing here, sometimes you may get the frustration of you're trying to import a file and it's not able to find it. Couple of reasons for that. That's really what this segment is trying to address. When a module name spam, we haven't actually created spam here, but I just want to, using this figurative speaking or as an example, when a module name spam is imported, the interpreter first search for a built-in module with that name. If it can't find that, then it search for a file named spam.py. In a list of directories given by the variable sys.py, whereby sys.path is initialized from these locations. What are these locations? The directory containing the input script or the current directory when no file is specified. Python path, basically a list of directory names with the same syntax as well as the shell variable path. And also the installation dash dependent default. So basically all of these are predefined. If it's not, then you will get an error. Now on file system which supports symlinks, which are Linux or Mac OS, the directory containing the input script is calculated after the symlink is followed. In other words, the directory containing the symlink is not added to the module search path. Now after initialization, Python programs can modify this sys path. The directory containing the script being run is placed at the beginning of the search path, ahead of the standard library path. This means that scripts in that directory will be loaded instead of modules of the same name in the library directory. So just understand that there is a possibility of this quirky behavior if you actually, or should you decide to modify this sys.path. One of the way is to actually just run this sys.path just to see what's actually what kind of path can you access. All right, so that's pretty much all that I want to cover for this module search path. Some of probably the best way is to actually place it in the same directory, but if you want to actually keep it a little bit tidier, you want to put your utility modules or supporting modules in a separate so-called folder. You can access it as well by putting the folder name dot the file name. So let me just show you before we end this. So let's just say I have this folder here. Okay, so we are right now in this folder called fibo.py, well, with fibo.py, test.py, and also rem. Okay, and don't worry about this Dunder file name here. rem is a folder. As you can see, this is actually a folder here. Now, within rem, there is actually another file called remem.py. What does remem do? Remem basically have very simple line, one variable defined, please remember me, and then print the value of name out. Now, if you want to import remem.py, how do you actually do that? So let's just run a simple IPython interpreter. So in order to import remem, this is what you need to do. You need to actually type the folder name and followed by the file name. Okay, when you've done that, you run that, what you get is actually, please remember me. And you should actually have, well, name is not defined, so let's just see if remem dot. Okay, so you get that. All right, you can actually access the name that's been defined. As soon as you import it, you actually have the name or the value that is in name being printed out. So that's really how you import it. So you import the folder name dot by the file name. Okay, so that's really the end of this segment here on module search path. I look forward to seeing you in the next lesson. Alright, so let's look at some standard modules that comes with Python. These are the pre-installed modules. There are lots of them. I just want to touch on some of them just so that it actually help your jobs a lot easier when you are working with other modules. There is this dir function, well, I call it directory. So let's just import sys. When you type dir, what it does is that it actually provides you with a directory of the so-called predefined modules and functions that's listed out for you. Okay, without arguments, the list the names that you have defined currently within it. Okay, so if, for example, here this dir sys lists down all the predefined functions modules that is within sys. Okay. What happens if you actually don't put any names? It actually lists all the so-called names that you have defined currently. So you should be able to find A in here, right there. That's A. And also notice that we have fib2 from earlier, and also a few other built-in functions that helper functions that Python import. Note that the list all types of names, variables, modules, functions, etc. There does not list the names of built-in functions and variables. If you want a list of those, they are defined in the standard modules built-ins. Import built-ins and then and you will notice that these are all the built-in standard modules. Okay, so keep that in mind. These are the built-in standard modules. There are a lot of them, and some of them are to actually provide you feedback on the errors, syntax errors, type errors, and stuff like that. Okay, so that's really a quick tour on the dir function as well as the standard modules. There are a whole lot more. You can actually look up the library reference for more. But for now, that's really the one that I want to touch on, just so that it can get you started on the exploration of what are the so-called, first of all, locating or identifying the names that you have defined right now, and second of all is look at all the so-called modules, standard modules that's defined within Python itself. Hi, welcome back. We are going to look at packages. What are packages? Packages really is a way of structuring Python's modules, the namespace by using a dot module names. This is really a way of tidying it rather than importing multiple modules. Sometimes the package contains many modules within it. Now take for example the module name a.b designates a submodule name b within the package name a. So that's one way for you to actually instead of writing multiple lines of import, you import one and it actually covers the whole, well, import one package and brings in all of the so-called modules itself. So just like the use of modules saves the author of different modules from having to worry about each other's global variable names, the use of dotted module names saves the author of multi-module packages like NumPy and also the Python imaging library from having to worry about each other's module names. Now suppose you want to design a collection of modules or a package. Okay, when you have a collection of modules, it's called a package. For the uniform handling of sound files and sound data, there are many different sound file formats. Okay, so you need to create and maintain a growing collection of modules for the conversion between the various file formats. There are also many different operations you might want to perform on the sound data. So in addition, you will be writing a never-ending streams of modules to perform these operations. Here's a possible structure. Okay, so it's expressed in terms of hierarchical file system. So at the top end, you have the sound. Within the sound folder, this is the sound folder. Within it, you have init.py, and then you have the format subfolder, and then you have another init, and then you have a long list of py file. And then there's the formats folder, effects folder, and then filters folder. In the vernacular or terminology of package, this is the package, followed by these are the packages, and these are the so-called modules itself. When you import the package, Python searches through the directories on sys.path looking for the package subdirectory. The dunder init dunder.py files are required to make modules treat the directories as containing packages. So it's your dunder init dunder.py file that actually defines all of the so-called modules that belongs to this. So that's really where you actually provide all of the information for Python to actually pick that up. This is done to prevent directories with the common name such as string from unintentionally hiding valid modules that occur later on the module search path. In the simplest case, dunder init dunder.py can just be an empty file, but it can also execute initialization code for the package or set the dunder or dunder variable described later. User of the package can import individual modules from the package. For example, import sound.effects.echo. So we have import sound.effects.echo. This load the submodule sound.effects.echo. It must be referenced with its full name. Okay, and you can also do this. All right, that actually call up. Don't worry about these. These are just some of the so-called positional as well as keyword argument. An alternative way of importing the submodules is from sound.effects import echo. This will load the submodule echo and makes it available without its package prefix, so it can be actually made use of this way. If you import it this way, then you need the whole long list plus the method itself. If you import it this way, then you just need to echo filter. All right. Hence removing the prefix. Yet another variation is now you define all three, you import directly the actual function itself. Now you just need the function name and you can use it right away. Note that when using from package import item, the item can be either a submodule or subpackage of the package or some other name defined in the package like a function or class or variable. The import statement first tests whether the item is defined in the package. If not, it assumes it is a module and attempts to load it. If it fails to find it, an import error exception is raised. Okay, so those are the key things to bear in mind when you're actually working with the package. Number one, you do need an init.py file, and the way that you import also matter as well. You can either use import everything or from some subpackage import the function, or from the package subpackage module import the function directly. Okay, there are other ways to import, such as import star from a package. Now, what does that mean? Let's look at this. Now, what happens when the user writes from sound.import star? Ideally, one would hope that this somehow goes out to the file system, finds which submodules are present in the package, and imports them all. This could take a long time, so while this is not really ideal, and also may have unintended consequences as well. So the only solution is for the package author to provide an explicit index of the package. This is where the init file comes in. The import statement uses the following convention. Okay, if a package init.py code defines a list name, or it is taken to be the list of all module names that should be imported from package.import star is encountered. It is up to the package author to keep this list up to date when a new version of package is released. Package authors may also decide not to support it if they don't see a use for importing star from the package. Okay, so just keep that in mind. Okay, take for example effects. If you look at effects, you have three files here: echo, surround, and reverse. So dunder or dunder means here it's has these three names, three lists, one list with three names in it that defines. This would mean that when you actually import from sound.effects import star, would import the three named submodules. Okay, that's how you actually do that. What happens if dunder or dunder is not defined? The statement from sound.effects import star does not import all submodules from the package into the current namespace. It only ensures that the package sound.effects has been imported, and then import whatever names are defined in the package. This includes any name defined by init.py. It also includes any submodules of the package that were explicitly loaded by previous import statement. So let's just consider this statement. import sound.effects echo import sound.effects.surround from sound.effects import star. Okay. In this example, the echo here and the surround here are imported in the current namespace because they are defined. Okay, effects, echo, sound, reverse. So echo will be imported, sound will be imported. What about the third one? The first two is predictable because you specify the actual module to be imported. Okay. Although certain modules are designed to export only names that follow a certain pattern when you use import star, it is still considered bad practice in production code. That's one of the key things here. In this example, echo sound are imported in the current namespace because they are defined in the package when the from ... import is executed. This will works when all is defined. So when you actually import this execute the last line here, it's very unlikely that echo and sound will be imported unless it is defined already in the this file here, okay, or within the init file with the or defined. Okay, so just keep that in mind. Okay, so we finish off these last two key things, and that's pretty much wrap up this section. So intra-package reference. When the packages are structured into sub-packages, such as those that we looked at earlier, you can use absolute imports to refer to the sub-modules sibling packages. For example, if the module sound.filters.vocoder needs to use the echo module in the sound.effects package, you can use from sound.effects import echo. Okay. You can also write relative imports with the from modules import name form of import statement. Some example you can look at is from dot import echo, from dot import formats, from dot import echoes, which is that one there, from dot import formats, which is that one there. Dot means go up one, dot meaning go into the directory echo. From dot filters import equalizer. Note that relative imports are based on the names of the current module. Since the name of the current module is always main, modules intended for use as the main module of Python application must always use absolute imports. So just keep that in mind when you're actually using intra-package references as well. And one key thing is, and also a good practice is to just write it in, because this can be a bit ambiguous if you are looking at it for the first time, compared to if you define it this way. It's very clear. There's no ambiguity with it. Although, yes, it is a bit longer to write this out. This is probably more convenient, but it gets a bit painful later on when you want to actually audit your own code for errors. Packages in multiple directories. Packages do support one more special attribute called path. This is initialized to be a list containing the name of the directory holding the package init.py before the code in the file is executed. This variable can be modified. Doing so affects future searches for modules and sub-packages. While this feature is not often needed, it can be used to extend the set of modules found in the package. Keep that in mind. It is quite a useful so-called functionality that's available. Although it's not frequently used, it is nevertheless available. Welcome back. In this segment, we're going to go into input and output from many perspectives. So let's just get into it. There are several ways to present the output of a program. Of course, you can actually have it output onto the screen or output it onto a file. It's really completely up to you. But Python, the beauty of it is that it offers all of these options to you. So let's just start with fancier output format. This is about outputting something onto the screen or the console, sometimes it is called. There are two ways to format your output. The first way is to do all the string handling yourself using string slicing and concatenation operations you have learned earlier. Now, the string type has some methods that perform useful operations for padding string to a given column width. This will be discussed shortly. The second way is to use formatted string literals or the str.format bracket method. We will go through some of these examples. The string module contains a template class which offers yet another way to substitute values into string. Again, we will cover those as well. There's one more question that remains, of course. How do you convert values to string? And fortunately, Python provides this function called str that allows you to do that. Of course, you can use repr as well. My personal preference is str. The str function is meant to return representations of value which are fairly human readable, while repr is meant to generate representations which can be read by the interpreter. For objects which don't have a particular representation for human consumption, str will return the same values as repr. Okay, so let's get started. What we have here is that we're trying to store the value hello, comma, world, full stop into s. All right, so we're trying to assign a string. The str basically converted into a format that is human readable. If you look at repr, notice that it added the so-called double quote on the side. Of course, you can actually have just s on its own, and you will see that it is actually very similar to str. We will show you later a little bit on str with some more examples. So if you print repr, it will remove the double quote. Okay. Right, let's have a look at the str a number, 1 divided by 7. Now, looking at that, you know that it's going to be a float. So let's have a look what happened to the str. It converted into a string. Now, I know it doesn't look like a string, especially if you're not familiar with it. So let's just run it like that and see what it looks like. Notice that when it's a number, it doesn't have the quote, single quote. Okay, so when you actually convert it to a string, you will see the actual single quote. That is really what str does. It converts it into a string. So let's look at some more example. You have x is equal to 10 times 3.25, y is equal to 200 times 200, and then you have s is equal to single, the value is up to this point. Okay, so this part is string, plus repr, meaning converting the x, the result of x, of this multiplication into a string, plus bracket with a comma, and y is plus, again, another repr, y plus dot dot dot. So, and then we print s. Let's have a look what it looks like. And what you get is exactly that. It's human readable because of the print. So that's the actual functionality of repr in combination with print. The repr of a string adds string quotes and backslashes. So hello is equal to hello world. /n means a new line. Hellos repr world. So now we're actually converting the hello into hellos, basically converting it into a string. And let's see what it looks like when you actually do print it. Notice that the /n is still there, okay? And that's one of the beauty of repr is that it actually retains that because it adds the actual string quotes and backslashes. Right, what happens if you have this? Okay, so you have a tuple here. You have x, y, and then another tuple. So when you repr it, and you will notice that, remember x is from here, okay? So it allows this to come through, but these are not strings, okay? So you can actually provide as an input any so-called arguments into REPR. Okay, so that's really what this is saying, is that the argument to REPR may be any Python object. There are two ways to write a table of squares and cubes. All right, so let's compare this. You can print these are numbers, and now there is actually a print with a space at the end, and this is what it looks like. Now note the use of n on the previous line. Now n here basically means that we have a new line. Okay, so now what happened is that if we actually use REPR, okay, and we're using write justify 2, write justify 3, write justify 4. So let's run this and print this, and notice that you can format it in a way that is much more pleasing to the eye. And finally, you can also do it this way, and when you print it, it's actually generate the same result. Okay, now I went through those codes very quickly, so let's come back and revisit this. What are we doing here? We are trying to actually print a table of sequence. Okay, the sequence is squares and cubes in this case. And you notice that when you actually just print the number, the so-called visualization, which is this one, it's not so nice. Like, it just doesn't come out very nice at all. That's because of the alignment issue. Alternatively, if you actually have an end to it, which is a slight variation to this, it doesn't actually seem to change much. All right, the visualization is still very similar. So one way to do it is to make use of REPR, and then write justified by 2, REPR write justified by 3, and then REPR write justified by 4. And when you actually do it this way, it actually write justify, and just need to make sure that your spacing is correct. Now you do need to specify this based on the length of your numbers, because this is 1000, 4 digits, that's why you have to use 4 here. The most common way, since Python 3 came along, is to make use of this method here. What is this method? It's basically you preset the format. Okay, so this is 0, refer to index 0, this is 1, refer to index 1, and this is 2, refer to index 2. And then you have 2 decimals, 3 decimals, and 4 decimals. And running it this way, what you have done is that you actually have provided the spacing in according to how you like to have it display. Now notice if I do it wrong, and this is what happened, the alignment is off. So hence you actually do need to specify how many decimal correctly. Okay, note that one space between each column was added by the way print works. It always adds spaces between its argument. This example demonstrates the string.rJustify method of string objects, which write justifies a string in the field of given width by padding it with spaces in the left. It's very similar to ljust or str center. These methods do not write anything, they just return a new string. There is another method, which is str.zField, which pads a numerical string on the left with 0. It understands about plus and minus sign as well. So we have 12 here, zField 5 means we actually have 1, 2, 3, 4, 5, and then basically we're wanting to achieve 5 decimals or 5 digits, sorry, I should say. And so in order to fulfill the 5, it needs to actually add 3 leading 0. Likewise with this, 7 digits, 1, 2, 3, 4, 5, 6, 7, and also if you actually have a number that's much longer, then that field 5 will not work at all. It won't throw out an error message, but it will just continue as per normal. Okay, now there's this function called str.format method, which we've seen it slightly earlier. You can actually do it this way. So we have print, this is actually a placeholder referring to the first index here, and then you have another placeholder which refers to the second index here. Now notice the format here. You have print with bracket and then single quote and then followed by dot format. Within the quote itself you provide the parameters. If you have two parameters here, then you refer to it in the sequence. If you want to switch the sequence, then you actually have to provide an index number. Okay, let's run that. Okay, so you notice that we are the nights is actually being used to replace this or remove the so-called placeholder. Say 9, it replaces the placeholder. The brackets and characters within them called format fields are replaced with the objects passed into the str format method. A number in the brackets can be used to refer to the position of the object passed into the str format method. So if I do it this way, 1 and 0, you will notice that it becomes no longer the result becomes we are the knights who say 9. It will become we are the 9 who says night. So let's run this. Okay, notice that it's switched. Okay, so that's what this numbering is for. Here's another example. We have two inputs, spam and eggs. In the normal sequence, 0 and 1, you have spam and eggs. But now that we switch 1 and 0, you will have eggs and spam. Okay, so that's precisely what that function actually is for. Now, if keyword arguments are used in str.format method, their values are referred to by using the name of the argument. Okay, so if you actually have the keywords arguments used. So here we have an example of two keywords argument, which is food and adjective. Okay, we have spam and absolutely horrible. Then when you print this, and then notice the placeholder, the squiggly essentially, or the curly bracket essentially is the placeholder, and you notice that you can actually use the keyword argument as the placeholder now. So you will get print, this spam is absolutely horrible. You can also combine positional and keyword arguments as well. So you have 0, 1 and other, you have 0, 1 and other. So what you will get now is that the story of Bill, Manfred and George. Okay, when you have an apostrophe A applying ASCII, apostrophe S is applying string, and apostrophe R applying RAPR can be used to convert the value before it is formatted. Okay, so we have here contents use, print. My hovercraft is full of the contents, which is use here. So if we do that, it will just look like this. Now, what happens if I put an apostrophe R that refers to this, which is RAPR? So we should actually have a double quote, okay, or single quote in this case. Okay, single quote here. You can also have an optional semicolon, and format the specifier can follow the field name. Okay, so we'll show you how that works. Let's import from the modules or the package called mathematics, and we want to make use of the variable called pi, or constant called pi. As you know, pi is very long, 3.14, and then on it goes. So what we want to do here is that the value of pi is approximately 0, which is referring to this. Column here is just a place, and basically this is actually informing Python what's to follow will be a format specifier. So you have 0.3 float. 0.3 means 3 digits. Okay, 3 digits after the full stop. So run this. So you have that full stop. You have 3 digits. Okay, so it becomes 3.142. Now, if you are passing an integer after the column, it will cause that field to be a minimum number of characters wide. This is useful for making tables pretty. Here you have the table. You have, don't know how to say this, Trojan 4127 Jack, and then decap. And now you're actually iterating through this for name. and phone in table.items. So basically from the table you are actually retrieving the item one by one, and then you have the key, and then you have the value. So you print first, which is index 0 with 10 characters wide, and then you have the first index and then also 10 characters wide. So that's to format it nicely like this. If you have a really long format string that you don't want to split up, it would be wise or nice if you could reference the variables to be formatted by the name instead of by position. You can do this by simply passing the dig and using square bracket to access the key. The same table that we have before, so you can print Jack, and then now is 0, meaning referring to index 0, and then you're trying to retrieve Jack, which is Jack here. Okay, so that's what you're actually trying to refer to, but what you're actually retrieving here, you're providing this key, you're retrieving the phone number, and you're doing it for all three. Okay, so you have Jack, which is this portion here, and this is using this key to retrieve the so-called phone number. This could also be done by passing the table as keyword arguments with the asterisk notation from our earlier class. So you can actually use this to unpack it. And notice that it actually unpacks it really nicely for you. Okay, so this is particularly useful in combination with the built-in function vars, which return a dictionary containing all local variables. For a more complete overview of string formatting, do have a look at these. Format string. This is just a really quick tour of how you actually conduct string formatting. I hope that has been useful and informative for you. Hi, welcome back. In this segment, we're going to look at how do you read and write files. There are other built-in modules that can also read and write files really well. But for now, we're just going to make use of the standard Python and see how we can actually do this. Right, in Python, there's a couple of objects that's built in to assist. You have open, which returns a file object, and is most commonly used with two arguments. You have open, and then you need to provide the file name and also the mode. What is the mode? There are different modes that you can actually have here. You can just read only, write only. A here means to append data, and R+ means that you can read as well as write. Okay, if you leave out the plus, then it will be assumed that it's just read only, which is over here. Now, normally files are open in text mode. That means you read and write strings from and to the file, which are encoded in a specific encoding. If encoding is not specified, the default is really actually platform dependent, so that gets a bit tricky. B here appended to the mode opens a file in binary mode. Now the data is read and written in the form of bytes object. The mode will be used for all files that don't contain text. I'm going to leave those and just focus on this part here. So in terms of the formatting or the actual approach here, it's a good practice to use the with keyword when dealing with file objects. Okay, so this should probably not be here. Instead, we should use the with keyword when dealing with file object. The advantage is that the file is properly closed after it finishes. Okay, even if an exception is raised at some point. Exceptions we will go through in the next segment of the learning. Using with is also much shorter than writing equivalent try and then finally blocks. Again, we'll cover that in the next part. So with open Word file as F, then your read file is read data, which is the variables we're storing, is equal to f.read. So this is really the actual format here. If you're not using the with keywords, then please make sure that you do actually have file close to ensure that the resources are being freed up. Now, after a file object is closed, either by a with or by calling f.close, attempts to use the file object will automatically fail. Okay, looks like there's a typo here. Okay, right. So, we will go into these methods of file objects and demonstrate it with an example after this. Welcome back. Hey, let's get into the actual reading of file. Let's start with that. So to read a file's contents after it's open, you use f.read and size. Basically, it reads some quantity of data and returns it as a string in text mode or bytes object if it is in binary mode. Size is actually optional. This is optional numerical arguments. When size is omitted or negative, the entire contents of the file will be read. Okay, so if you leave it out, it will read everything. This is quite a useful method, especially when you are reading large files that cannot fit into memory. This is one way for you to actually manage or control that. Otherwise, at most, byte size are read and return. If the end of the file has been reached, f.read will also return an empty string. Right, so let's start with read. Okay, let me just show you a little bit of the directory itself. I have put a file here called wine.csv. So it's a CSV file. Okay, so right, let's follow these line by line. Line number 1 basically say, all right, create an empty list, okay, and store it in this variable called read_data. Now, these 2 lines basically means that we are opening this file, open wine.csv as f, okay, so we're actually instantiating it as f, all right, then you read a file by f, which is this here, f.read. So this f.read, in essence, is this object here or this method here reading the file. And since we didn't specify size, basically we're going to read the whole thing and store it in read file. And then f.close bracket is just to close the file. So let's run that. It will read that file, okay, and when you get a number like that, that means it's successfully read. So let's just print the data of read data, and this is what it looks like. What you have is it's a list of numbers, and then you have /n, which is actually a new line. So basically you have this as one long stretch of string. Once you actually have that, the next thing that you do need to actually make some modification is you can use a for loop, okay, in reading the data for line in read data and then print them. Okay, and what you will get is this. All right, so this is the actual file. It looks or resembles something that you can actually, well, work with. It's a lot easier to work with than before. Right. In the next video, we're going to go into reading line by line rather than reading the whole file. Okay, in this segment, we're going to do read line instead of reading the whole file. Now, f.readline reads a single line from the file. And when you encounter a new line character, which is backstroke n, it's left at the end of the string and is only omitted on the last line of the file if the file doesn't end with a new line. Now this makes the return value unambiguous. If the read line returns any empty string, that means we have come to the end of the file. So that means it's reading line by line. When it encounters /n, okay, that means we need a new line. at the end of the file will be an empty string. We have come to the end of it. So we are doing this. F is equal to open 1.csvr. Notice that we haven't closed the file or built into the close as we mentioned before. So run this. And now we're reading the first line. Okay, so that's what this is, reading the first line. And then when we run this again, we're reading the second line, and on it goes. So essentially, this is a little bit like what we did earlier here, except that we're doing it manually in a slow manner. So next thing is we do need to close the file by running that. So if you want to read lines from a file, you can loop over the whole file object. This is memory efficient, fast, and leads to a simple code. You first have to create an empty list with open file, open.csv as f. For line in f, you append the so-called line that is read. Remember, we are reading so-called from f for each line. Okay, we are actually extracting it, and then we're stripping the actual /n of it and then append it into file data. Okay, make sense? Hope that is actually useful. So run that. Okay, and when you actually f close means has the file been closed? The answer is yes. So when you actually print file data, and this is what you get, everything is actually stored into a list here. Okay, so that's really some of the so-called method that you have here is actually to read the files line by line. Okay, and that's one of the way that we can actually attack this. Okay, so having done that, what we'll do next is actually attempt to write this contents to the file. Okay, and returning the number of characters within. So we have this new line here that we create, and we open testfile.csv and write. Okay, and we write this new line into the test file, and then when we close it, basically that means that it will be stored into the file itself. Now, how do we know whether this has been done successfully? You can actually write the code if you want to. What I just want to do now is just what is the file called? Testfile.csv. So let's just select this and have a look, and you'll see that there we go. It's been successfully written into the file itself. So if you actually have a lot of data, you can again use the for loop to actually save line by line. Right, that's really these very straightforward topics that I wanted to cover on reading and writing files using Python. You can use, of course, the read function, you can use the readline function, and finally the write function here. So with that, I'm going to end this video. We're going to move into a JSON after this. All right, welcome back. We're going to look at JSON now. Now, strings can easily be written to and read from a file. Numbers takes a little bit more effort since the read method only returns a string which will have to be passed to a function like int, which takes a string like a single quote 1, 2, 3 and returns its numeric value 1, 2, 3. When you want to save more complex data types like nested list and dictionary, parsing and serializing by hand becomes quite complicated. So rather than having users constantly writing and debugging codes to save complicated data types to file, Python allows you to make use of this really popular data interchange format called JSON, okay, or JavaScript object notation. The standard module called JSON, which is actually inbuilt, can take Python data hierarchies and convert them to string representation. This process is called serializing. Reconstruct data from the string representation and is called deserializing. Between serializing and deserializing, the string representing the object may have been stored in a file or data or sent over a network connection to some distant machine. Right, so let's dive in. That's enough theory. So we have import JSON because we need to make use of this library or method. If we dumps, okay, what is really a list, 1 comma string simple and string list. If we dump it onto screen, this is what it looks like. Okay, there is another variation of dump, so it's called dump, which simply serializes the object to a text file. So if f is a text file, object open for writing, we can do this. We can just dump into the file. Okay, the x being the data and f being the so-called file. To decode, you just load. Okay, right. There is another method called pickle, contrary to JSON. Pickle is a protocol which allows the serialization of arbitrary complex Python object. As such, it is specific to Python and cannot be used to communicate with applications written in other languages. So notice the difference here. Pickle, it's really specifically for Python, whereby JSON is actually, well, it can use it on any machine by and large. Right, so if we look at this, we want to dump this into X data. And we're going to open this file and to write, and we write the X data into it, and then we're going to close our file. Alright, so that's JSON test file.csv. So let's go back to our Python modules and look for the file under page 2. You see the JSON test files, so let's open that up and have a look. And there we go. There you have this list being stored correctly. So what happens if I want to retrieve it within Python? You can do the reverse, open the file as a read file and load the data, okay, with file f as being the object after it's instantiated. And then when you print y, it's basically retrieving this list from earlier. And finally, don't forget to close the file. So that's really the end of the portion. I want to quickly touch on JSON. This portion is really not meant to be very in-depth. It's just to actually touch on it so that you can actually understand that these methods or these packages do exist, so that when you actually come around with the need for it, you can actually access and make use of it. Welcome back. In this segment, we want to look into errors and how do we actually handle errors properly. There are at least two distinguishable kinds of errors. You have syntax errors and you have exceptions. So let's look at them one by one. This part is a little bit more on the theory side, so bear with me. Syntax errors, also known as parsing errors, are perhaps the most common kind when you actually make use of Python. So here's an example. These codes are written incorrectly, so that's why you get this syntax error, which a great explanation, invalid syntax. Wonderful. But there's some don't mock it, it's still very useful. The parser repeats the offending line and displays a little error. Notice there's this little arrow here just in case. It's actually a caret pointing the earliest point in the line where the error was detected. The error is caused by or for at least detected at the token preceding the error. So in the example above, the error is detected at the function print, since a colon is actually missing before it. File name and line numbers are printed so that you know where to look in case the input came from a script. So that part I really like, it's very handy, makes it a lot easier for you to actually locate the problem. The next kind of errors is called exceptions. Even if a statement or expression is syntactically correct, meaning you write everything very Pythonic, it may still cause an error when an attempt is made to execute it. Errors detected during execution are called exceptions and are not unconditionally fatal. You will soon learn how to handle them in Python programs. Most exceptions are not handled by programs, however, and result in error messages as shown here. So with these we can handle. Okay, if a syntax error we can't really handle, you have to actually go back and rewrite it properly. So obviously what you have here is that it's basically using Python as a calculator, but it's a number divided by 0. And I'm sure if you learn it from high school that anything divided by 0 is it's undefined. So you're going to get an error. And that's what it says here, 0 division error, because it's a division by 0. Alternatively, you might have something 4 plus. Well, we haven't defined what is spam. Again, you're going to get an error. Well, the name spam is not defined. Or you're trying to add string to a number. Okay, again, must be string, not integer. So you get all sorts of problem that's like this. You have 0 division error, you have name error, and then you have type error. Okay, so the last line of the error message indicates what happened. So that's what this last line is. Exceptions come in different types, and the type is printed as part of the message. The types in the example that I've given in this tree is you have 0 division error, name error, and type error. That's actually as useful as it, or as informative as it gets. So part of the art of being a good programmer is learning to read it and understand what that means. And quite often you will actually make use of this, right? Copy this and go onto Google and find out, hey, now what does that actually mean? All right, that's pretty much it in terms of the theory. When we come back, we will learn how to actually handle exceptions. Welcome back. In this portion, we're going to look at how do you handle exceptions. You can write programs to handle exceptions, not so much syntax error, but handle exceptions. So let's look at these codes here. While it's true, we will try receiving the number from the user. Basically, it's asking for an input from the user. If it's correct, then it will break out of the while loop. Okay, and if however the user enter not a number such as string, it will print the value error and say, oops, that was no valid number. So let's try again. So we're going to try this. Try. Okay, oops, that was not a number. Then you ask why. Okay, it's not very smart. So if you want to stop, any number will stop this program. Okay, then it stopped right away because there is that break there. So the try statement works as follows. First, the try clause is executed if the try, meaning these two lines here, okay, this block of codes here. If no exception occurs, the except clause is skipped and execution of the try statement is finished. If you get an exception, okay, during execution of the try clause, the rest of the clause is skipped. So when this is actually raise an error, it will quickly jump to this except. Okay, so the except is kind of like a catch-all. All right, when you actually have an error, exception, error. Okay, if an exception occurs which does not match the exception named in the except clause, it is passed to outer try if there is another try outside. Okay, if no handler is found, it is an unhandled exception and execution stops with the message as shown above. Okay, so that's very useful there to help you. So typically, a try statement may have more than one except clause so that it actually picks up all the different types of exceptions. At most, one handler will be executed. Handlers only handle exceptions that occurred in the corresponding try clause, not another handlers of the same try statement. Okay, so that part is actually quite important. We also talked about this. An except clause may name multiple exception as a parenthesis tuple, such as except you have runtime type error and also name error that picks up everything. So the try and except statement has an optional else clause, which when present must follow all except clause. That is useful for codes that must be executed if the try clause does not raise an exception. Okay. Now, having done that, there's just one key thing that I want to mention here is that when you write codes, it's actually a very good practice to do this. Try and accept. If necessary, then you use the else. Reason being, you have no idea what kind of input that you may get. Having this make your code much more robust and makes it a lot easier to handle error and don't actually give you some sort of weird behavior. All right, with that, I'm going to stop. We already covered this really key concept here on how to handle exceptions. When we come back, we will cover race exceptions. Welcome. In this portion, we're going to look at raising an exception. There is this statement called raise, which allows the programmer to force a specified exception to occur. Sometimes you use this to actually bring it to your own attention. It's kind of like for debugging purpose. So when you actually have a raised error, hi there, okay, so it will print hi there. So you are the one that actually specify what kind of output you want to receive so that it helps you to diagnose where the problem lies. So you're going to try raising a name error, except name error will print an exception flew by. So what you have here is that the moment that the raised name error is executed, the except will not be actually executed. So that's where you actually get this name error. Hi there, it's exactly the same as that. So just be mindful of that kind of behavior. Now let's move on to try or defining cleanup actions. The try statement has another optional clause which is intended to define cleanup actions that must be executed under all circumstances. For example, you have try, raise a keyboard interrupt, and then there is this finally. Okay, finally is basically is the last action that you will actually execute. Okay, so it still have goodbye world despite having a keyboard interrupt error being raised here. A finally clause is always executed before leaving the try statement. So that's the key part of this behavior, whether an exception has occurred or not. When an exception has occurred in the try clause and has not been handled by the except clause, it is re-raised after the finally clause has been executed. The finally clause is also executed on the way out, okay, when any other clause of the try statement is left via a break, continue, or return statement. Okay, so let's try this. Okay, we have defined a function called divide, x by y. So you try the results x divided by y. If it's division by 0, then you will print division by 0. Otherwise, print the result. And finally, when it's all done, when you actually want to stop, it will have the executing final clause. This is to tell you kind of like a bye-bye. So 2, 1, okay, that you have running in this line of code because there's no error being raised. It print the last line as well, the finally clause. And what happens if it's division by 0? You'll get it will get caught by this except 0 division error, and then it will print this line. And then after it's done executed, on the way out, it will print executing finally clause. Okay, and what happens if you actually have string divided by string? Well, the thing is that we don't actually have so-called a handler for that situation, where it's called type error. But on the way out, it will still print the finally clause. As you can see, the finally clause is executed in any events. Okay, the type error raised by dividing 2 strings is not handled by the except clause and therefore re-raised after the finally clause has been executed. In real-world applications, the finally clause is useful for releasing external resources such as files or network connections, regardless of whether the use of the resource was actually successful or not. So that's really the end of this really quick tour on errors and exceptions. It's really designed to bring it to your awareness of the possibility of handling exceptions. Not so much syntax error, but more so for exceptions. I hope you found that useful. Thank you for watching.